Hello, 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 folks. How are we doing today? We're going to get started here in about 1 minute. Hey, Copper Lily, good to see you. Hey there, Ahmed. Y'all are having a good weekend. Oh, sorry to hear that, Copper Lily. Yeah, no worries. Just listen in. That's all good. Hope you feel better soon. Alrighty. Hello, 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 folks. How are we doing today? Hope everybody is doing well. Copper Lily, I hope you feel better soon. But I hope y'all are having a great weekend so far. I know I am. Um, been a lot of fun so far. The weather's kind of gross outside, so it's a good day to be inside and streaming and doing some SQL, which is what we're planning on doing today. Ahmed says, doing great. I'm doing your WebSocket chat app. It's really helpful for learning WebSockets. Oh, good. I'm glad you're enjoying that one. That one was super fun to do. I really enjoyed building that. Um, and yeah, that's the first app I've ever built with WebSockets. So that was a really fun learning experience too while I was building it. And so, just a couple of housekeeping things before we get started today. Um, I am planning on moving some more videos over to YouTube here pretty soon. So, expect to see that. Look out for announcements on Twitter when I do release those videos. I have several that are sitting in private right now. I just need to finish editing them and then make them public so y'all can see them. And then I'll move a few more streams over as well. So we should have a pretty good group of streams moving over to my YouTube channel. The nice thing about my YouTube channel is that it is ad free and you can watch at your own pace and the videos will never expire. So if ads bother you as much as they bother me, then feel free to stop on over to my YouTube channel and watch them there with no ads at all. Um, because I have minimized ads as much as possible on my Twitch channel here, but unfortunately, Twitch doesn't let me turn them off completely. So if ads detract from your learning experience, then feel free to check out my YouTube. You can do exclamation point YouTube in chat if you would like a link to that, or if you're watching this at a later date and you're wondering how to get to my YouTube channel, you can head on over to YouTube and you can search for Mayan Wolf Streams, one word, Mayan Wolf Streams, or even if you just type Mayan Wolf, I've heard that my channel is the first result that comes up. So, so hopefully that makes it easier for you. Alrighty. Hey, Nemobit. Welcome. Good to have you here. I'm glad you're excited about SQL. I'm excited about SQL too. I'm always excited about SQL. Um, we'll give folks another couple minutes here. I know I said last week that I probably wouldn't be streaming today. So I'm sure some folks are going to be a bit blindsided by the fact that I have gone live, but the way my weekend ended up working out, I ended up having some free time here on Sunday. And so I thought, well, the weather is gross and cold and rainy outside. So might as well do this. And we didn't get through all of the problems that I wanted to work through last week. There's a lot of great concepts that we haven't talked about yet or that we just touched on very briefly last week. So I would very much like to spend a little time on stuff today. Who knows how long we'll go today? Maybe it won't be the full 3 hours. I know I just jinxed myself by saying that, but we'll see how we do today. All right, I'm going to take a quick hydrate here. I've got some nice hot tea. And oh yes, also if anyone watching this live on Twitch would wants or needs captions, closed captioning for my voice, you can hover your mouse over the right side. So here, about here, hover your mouse about here on the screen, and you should get a little pop up that has the closed caption icon. You can click that and turn captions on. New Mobit says, "Are you going to talk or have already about SQL where attributes? I always struggle with them doing queries." Yes, we did talk quite a bit about them last week. So feel free to check out last week's stream as well. Pretty much, I think we touch on where clauses in pretty much every SQL stream I've done. So if you like more practice on that, you can head on over to YouTube and just search for SQL on my videos tab. And you should find plenty of examples, plenty of practice for you to practice those concepts. But yeah, we are going to touch on it again here today, just because where clauses are such an essential part of most SQL queries. Pretty much every SQL query you're going to run, you're going to want to filter the results in some way, right? You're going to want to return a subset of the overall data in the tables that you're looking at, right? And so a lot of the times you're going to want to use where clauses to filter that data in some way and reduce the number of results that you get to only the ones that you need. So where clauses are extremely important in most SQL queries. Hey, chaotic, good to have you here. Welcome. I'm doing well, thank you so much. Ahmed says the perfect time to code is when it's raining outside. Yes, I very much agree. Yep. Yes. It's also a great time to be streaming as well. So but yeah, I'm in a pretty good mood. Had a great Doctor Who episode yesterday. I really enjoyed it. So I'm feeling good. All right. Nibo, it says, nice. I'm going to check on YouTube. Thank you. Yes. And we are going to cover where clauses during today's stream as well. So feel free to stick around or just head on over to YouTube. Either way is fine. All right, so real quick, let's do a quick review because we're going to be focusing a lot on more of the data analytics aspect. So a lot of the questions we're going to be doing today, the leak code questions we're going to be doing today, are a little bit more in depth than the ones we did last week. The ones we did last week were mostly about taking a single table and filtering the results. So it was really just select star or select certain columns from a single table and then filter those results using a where clause. But today we're going to get into a little bit more of the types of things you would do if you were using SQL for data analytics. And SQL and data analytics are really common. And if you're in data analytics, you're probably going to learn SQL at some point, just because it's the best and easiest way to talk directly to a database and filter your data and get a subset of data that you can then refine further using other tools. So using SQL is really built for data analytics. And when you pair it with something like Python or even Microsoft Excel, you can really extract a lot from some pretty gnarly data set. So that's what we're going to be focusing more today, is more of these data analytics concepts. How do I take data that's meaningless in its original tables, or just raw nasty data that's missing chunks or that's incomplete in one table, and then you have a second table that has the rest of it. How do you take that and turn it into something that and so, in order to do that, a lot of the times, what you're going to be doing is you're going to be using joins. And we talked about this a little bit last week, but to kind of refresh your memory a little bit, what joins are is when you take two or more tables, and it could be even two instances of the same table, which we're going to see today. But anyway, it's two tables, and you literally join them together row by row using one or more matching criteria. So those criteria are generally going to be specific fields in each table. For example, let's say that we have um, let's say that we have a product table, and then we have a price table, right? So our product, let's say our product table has details, like technical details about a product, right? Like such as the material that it's made of, maybe how many units were produced last month, maybe what year we started selling that product, right? And then we have a sales or a prices table, something that deals with the monetary aspect, right? Then it so in that table, we're talking more about, what is the price of this product? How, what is the monetary profit we made from this product last month? One of them is very physical. The other one is very monetary. And you'll see that a lot in tables. You'll see that they tend to focus on a particular subject. And if you want, let's say, to combine the data from those to say like, okay, do we make a lot of money on products that are made out of plastic, something like that? Are our products that are made out of wood or our products that are made out of plastic more profitable? Which is our more profitable product material? Which do we sell more of? Something like that. You're going to need to join those two tables together. And so a way that you might do that is something like a product ID. So for example, the product table with all its technical details is probably going to have a distinct product ID to identify that product. And the sales table will probably have the same thing. It's probably going to say, all right, for this product ID, we sold X, or this is the price that this product ID is sold for, something like that. And so you can join those two tables together on those unique values that are the same in both tables. And then you can return a subset of the results from both. So you can return as many columns as you want from either table, and you're just joining them together in your query. Now, there's lots of different types of joins. And so joins are often very scary to folks who are new to SQL. If you're new to SQL, you might see joins and you'd be like, oh my goodness, I don't know which join to use. I don't understand them. How do I link these tables together? How do I know which join to use? And I'm here to tell you that for more basic SQL, you should know at least three types of joins, and we're going to talk about all three. But in general use, you're really only going to use two, and so it makes the decision much easier when you're trying to decide what type of join to do if you only have to remember two types of joins, and we'll talk about those. Yeah, and Hot Bob, welcome to the stream, Hot Bob. Yeah, you already know which ones I'm going to talk about. The two types of joins that I suggest you remember are inner join and left join. Okay? Inner join and left join. Those are the two you should know how to if you're going to write SQL, or if you're going to go into an interview where you're going to be asked questions about. So inner join and left join. What does that mean when I say those words? Well, let's look at this graphic that I have here on the screen, because for me anyway, remembering joins is easier when I have something cool to look at. So this one in the top left here, this is what's called a left join. And you can see visually why that might be. So our circle here on the left is table A. Table A is what we would call our base table. It's the table we're going to start with. And then we're going to join another table to it. So we're going to join table B to table A in what's called a left join. And what makes it a left join is that we're going to preserve all of the rows from table A. So no matter what happens, we could potentially return all of the rows from table A without losing any data. However, from table B, we're only going to return the rows that match a row in table A based on the criteria we've specified. So if I say I want to join table A to table B on product ID, it's going to return potentially every product ID from table A, but from table B, it's only going to return the rows with a product ID that exist in table B. There might be more rows in table B for maybe, let's say, products we don't sell anymore. But since those product IDs aren't in table A, we're not going to return them from table B. So a left join means you return everything from the first table and only what matches on the criteria you specify from the second table. Okay? So here we're saying select, and then whatever you want to return, select something from table A, left join table B on, and then whatever criteria we specify. It could be more than one criteria. We could say join on, I don't know, product ID and product material or something like that. We could join on multiple criteria, but the gist is exactly what it says right here. Okay. Hi, randomness. Welcome to the stream. What do you mean practice joins and aggregation in SQL? Pretty sure it's standard practice to just get it wrong the first time and look up the differences between all of them every time you need one that isn't an inner join, as is tradition. That's funny. Welcome to the stream. Yeah, no, and there's nothing wrong with that. There is nothing wrong with getting it wrong, not getting the results you expect, and then trying a different join type. That's perfectly fine as well. A lot of the times, you know, crafting a SQL query involves building it slowly over time and refining the criteria until you get what you want. So that's perfectly valid. Welcome to the stream. Good to have you. Now, the second type that I want to talk about. So this is the first type you should know how to use is left join. And then the second type is this one right here in the middle called inner join. Oh, thank you for the follow, Hot Bob. So the second type that I want to talk about are inner joins. You can see here the Venn diagram looks a little bit different. It's much smaller. And that's because with an inner join, you're still starting with a base table, and then you're joining another table to it. But the only thing you return are the matching rows from both tables. So instead of returning everything from table A and only the matching rows from table B, you're only returning everything that exists in both tables. So in our example where we're talking about these products, it could be that there are some things that we have in our product table that maybe we have never sold. And so maybe there is no record of those in our sales table, right? So if we were to do an inner join, any record that doesn't exist in our sales table for a product that maybe we never sold or we discontinued or something like that, that would get dropped. It wouldn't return in our results set. And so it's really about when you're building your query, it's really about deciding how much data do I want to return. Do I want to see things that maybe don't have a match in table B that are maybe going to return null for some fields from table B? Like, do I care about nulls? Is that going to be a problem? If I do care about nulls and I say I want only complete data sets from both tables, then you would probably want to choose an inner join. But as randomness said, sometimes it's a little bit of trial and error. Sometimes you're not sure. Maybe you don't know how complete the data is in both tables. Maybe you're like, well, I think I have matching rows across the board, but I'm not sure. So let me just do this as a left join, and then I'll check for nulls and see maybe my data isn't as complete as I thought. So you run it as a left join, you see some nulls, and you're like, well, this isn't going to do. So I'm going to do an inner join. But then if you do an inner join, maybe you lose some data you wanted to have in the first place. So it's a little bit about feeling it out and deciding what kind of data do I really want to return. All right, let me catch up with chat real quick. Nemo says, theoretically, it reminds me the Eulero Venn diagrams done in math during high school. Ooh, fancy. I am not good at math. I will tell you that right off the start. That's why I work with computers because they do the math for me now. Dante, welcome to the stream. They say the people I work with always do left joins when they actually end up with an inner join. they, they left join where the filter is on a variable in the right table. Well, that's one way to do it. I mean, and yeah, you can fudge it a little bit, but it is better. It's better for readability. It's better for usability if you can simply specify the correct join from the start. Because if you specify the correct join from the start, that's going to tell the compiler engine, the SQL compiler, exactly how to execute that query. And so if the query is written properly with the correct join types up front, then it's going to run faster and more efficiently because the compiler knows what you want. So yeah, it's good to know the difference between these two. So these are the two that you should know you should know what they are. So just remember these Venn diagrams and what they do, and you should know how to use. You should know how to write a query with either of these in it. And we're going to practice some of that today. I'm just going over these concepts verbally first, so you have an introduction, and then we're going to do some practice on these. Now, the third one that you should know conceptually, you should know if somebody says, hey, what is this? You should be able to explain it verbally, is what's called a right join. So we have left joins, we have inner joins, and then we have right joins. Hey, Deb D, good to see you. So a right join is essentially the opposite of a left join, which makes, cognitive sense, right? Makes logical sense. So a left join is you start with a base table, and then you join your table B onto it, but you only return all of the results in table B and then only the matching results from table A. Even though you're starting with table A to begin with, if you're doing a right join, you're only going to return all the records from table B and the matching records from table A. So intuitively, it's a little funky, right? Is you're thinking, if I'm starting with a specific table and then joining something else to it, it makes more sense that you would want to, return everything from the first table and then only the matching records from the second, because why wouldn't you then just flip them around? But it's here. It exists. I don't use it very often personally. Primarily, the ones that I use for my work are left join and inner join. And if you know what those are and how to use them, you're going to be golden for most scenarios. And right joins, you should just know what they are, and know how to verbally explain it and draw the little Venn diagram of it, I would suggest. Hey, Mirhurs, thank you so much for the follow. Good to have you here. Hotbab says, so you can always write a right join as a left join if you flip the order. Um, you would have to probably edit the rest of your query as well to make sure that you're returning the fields that you expect from both tables. But I mean, essentially, they are the opposite of each other, as you can see here. They are you know, they are the opposite. Really, you're just controlling which table you're returning all the records from. So, do I want to return all the records from table A, or do I want to return all the records from table B? That's just the difference. But generally, I would use a left join just because it makes more sense logically. Umobet says, first time I see the attribute on. Yeah, we're going to practice that a little bit. Um, so the on clause here is how you specify the criteria on which you're joining your tables. So the engine has to know, how am I linking these two tables together? Because both tables are probably going to have a lot of columns, and it has no way of knowing which things you want to tie together, how you want to join those rows together. And so you have to tell it by using the on keyword. So you say, join, and then you're always going to have some kind of criteria to join those two things together. You could have multiple. You could say on product ID, so a dot product ID, b dot product ID, and then you could say, uh, uh, month sold equals month sold or something like that. So you can have multiple criteria, but the on parameter here is required for join. Yes, hotbob. Yes, that's basically it. Is it if if I was thinking about doing a right join for some reason, I would see if I could flip it and make it a left join instead, because that just makes more. D-Rock says we join tables on columns from each table. That's correct. Yes. So when I say something like product ID, I'm referring to a column in table A and then a column in table. No worries, Renitz. I think last week, Renitz, I said that I wasn't going to stream, and then here I am. So no, no harm done there. I know I think I said I wasn't going to, and then surprise. I was saying earlier that my schedule worked out a bit differently this than I planned. It was fine. Nothing went wrong or anything. I just had some spare time this afternoon, and it's a very cold and rainy weekend. So I thought, well, might as well. And I wanted to get through a few more topics that we didn't really have the time to cover last week, particularly spending more time on joins and spending more time on data analytics. So, how we can use SQL to actually get insights out of the data we're working with. Okay, so you can see, I mean, there's some other types of joins here, but really so like this down here, this is just a variant on left join. It's just saying, hey, where if the key in table B is null, then you get kind of a uh, a little bit less of a subset of table A and nothing from table B. And the same thing here for the right join. Now there's another type of join. I call it the forbidden join. This is what's called a full outer join. And you probably shouldn't do it in most cases. It's not something you're going to want to do most of the time, but you can still know it exists. Essentially, what it does is it returns every single record from table A, every single record from table B, and all the matching records in one data set. So you're slamming two tables together. Um, and so you're not only going to get all the matching records from both tables, you're going to get every single other record as well, whether it matches or not. And so when you're working with data, like data in like a corporation or like enterprise scale, if you slam two massive tables together and return every single record from both tables, you're going to have a bad time most of the time. So you don't want to do this, but it is a thing and it exists. Just don't do it though. Give all the things. Yeah, nope, don't do it. I did that once. I told this story last week. I did that once in my very first job. I was just learning SQL. I was just out of college, clueless kid out of college learning SQL, and I accidentally did a full outer join of two huge tables at like a major health insurance company. And the DBA, or the database administrator, literally hunted me down in my cubicle because I was slowing, like I was literally taking up too much memory in the database, but running my massive, poorly designed query. And yeah, she literally hunted me down in my cubicle and put the absolute fear of God into me. Yep. She was great. I loved her. She was like this Eastern European lady and like no nonsense. And she was fantastic, but she was terrifying. Loved her. Yeah, it was wild. Yep. So I never did that again, and that was a great lesson to learn. Yep. So don't do this. But yeah, so left join, inner join, and then you should know what a right join is. So if you just think of a Venn diagram, it should be pretty easy to remember. Hopefully. All right. Now that was a lot of talking. So I'd like to get into some practice problems now. But does anybody have any questions on joins, just in like the general concepts, general sense that we talked about here, before we go on to actual practice problems? Because if you're new to the stream, I'm always open to questions if they're sort of on topic for what we're talking about. Yes, if you ask them politely and they're related to what we're talking about, I'm usually happy to take a pause and answer them. And if you ever are not understanding something that I'm talking about, feel free to say, "Hey, I don't get it. Can you please explain it again?" And I will gladly do that. Hey, Motivate Matt, welcome to the stream. They say, so databases are always independent and you link them with queries. Okay, so let's clarify a little bit of terminology here. So, in a relational database, data is stored in tables, and that is what you are linking with queries. So, in a relational database, data is stored in a bunch of tables, which consists of rows and columns. So if you look inside of a single database, you're probably going to see quite a few different tables. And each of those tables is going to contain a specific kind of subset of fields and rows. So generally, it's going to be things related to the same subject, such as maybe transactions or sales or product information. Each of those three things could be separate tables. And that's great because you're keeping those tables fairly small, fairly focused on a particular topic. But if you're analyzing that data, you're probably going to want to know information that crosses those different subjects, right? I'm going to want to know things like, um, how many, what was my revenue from product ABC in the month of January, right? And so in order to do that, I'm going to have to link my product table probably to my sales table. And so with these types of queries, with these types of joins, we're not linking databases, we're linking tables together. So individual tables inside of a single database, we're linking those together with queries. And that's just a terminology thing. So when you're talking about relational databases, um, all those tables are stored in a big old bucket called a database. And the individual rows and columns related to a particular subject are stored in a table. And then inside each table, we have rows and columns. Now, the columns are sometimes called fields, and then the rows are sometimes called records. So going across horizontally, those are called fields across the top, so like the labels on the columns. And then each individual transaction, say, is generally called a row or a record. I hope that helps answer your question. Yeah. Rex says, I love it when experienced people teach less experienced people and don't disrespect them for things they didn't know. Yeah. I mean, why would you, right? Because everybody starts somewhere. I had to start somewhere. I didn't, like, people don't, spring out of the womb just knowing all this stuff. Everybody has to start somewhere. And it's a lot easier to get started if somebody is kind of helping you out along the way. People helped me along the way. I got a lot of help. And so why would I not help someone else because that was a nice experience for me. So let's pay it forward, right? Everybody should pay it forward. If you're good at something, and most of us are good at something, um, if you can help someone else with, learn how to do that thing, because in the end, it helps everyone, right? Eternal Defined Fox, good to see you. Petrazio says, "Why are certain joins not recommended? Still constantly mentioned all over. Can you give an example? Because a lot of the times, what I hear are folks doing, the most common join types are left join and inner. So if you have a specific example, I'm curious to hear what uh, what types of joins you hear mentioned all over. Got to know what not to do. Exactly. Some of the part of the learning process is also learning what you probably shouldn't do most of the time, right? Nemo says, "Do these sorry, do these concepts refer to non-relational DB?" So I can really only speak to MongoDB, which is the only other non-relational database type I've worked with. Um, and so non-relational databases kind of work in a different way. So if we're talking about something like MongoDB, that's what we call a document-based database. And so inside of a document-based database, every what we would call a record or a row in a relational database is actually stored as an individual object, an independent object that exists independently from every other thing in that collection, say. So each object is treated completely independently of everything else. Now you can link individual documents together using, like using references and things like that. So you can put a reference in your document to another document, but you're not going to be joining at a mass scale necessarily, like you would with a relational database. So you can still create connections in a non-relational database, but relational databases are really built to do this type of thing. They're built to do these types of mass joins of lots of records at once that exist in multiple tables. Rex says, "Oh, believe me, there are people out there who use their experience to shame others and disrespect them, not teach others." Oh yeah, and I've encountered that too. I'm not ignorant of that. But I think the best thing that we can do in turn is, number one, don't give those people our time and attention, and number two is to not do that and try to put more positive energy out there to inspire other people to then in turn put more positive energy out. So I think that's the best thing that we can do is, yeah, you're gonna encounter people that are gonna try to, talk down to you in your learning journey. They're gonna tell you that you can't do it, that you are not smart enough to do it, that it's that learning is not a good, I don't even know, that learning is not a good avenue for you to pursue. Why are you doing this? And I think the important thing is when you're learning is to make sure that the loudest voice in your head is your own. That make sure that you are the one that is in control of your motivation, that's in control of your thoughts, that you aren't letting people outside who are often maybe the louder voices outside of your head, right? The people who are speaking in your ear, don't let those people become the loudest voice inside your head because only you are the one that's in control of your destiny. All right, I'll get off my soapbox, but I think that's important for folks to remember. A lot of folks get discouraged when they hear people on YouTube saying things where like, "Oh, you shouldn't learn XYZ," or "Oh, don't, pursue a career in software development. Don't, why are you learning about databases?" All that kind of crap. Um, just make sure that those voices don't get too loud. All right. Divine Fox says, "Next course, NoSQL after this one." Actually, you'll find that most of my streams in my archive are NoSQL. So most of the projects that I build here on stream, if you look at my project streams, most of them are actually MongoDB as the backend. I have started doing some with Supabase as a backend using SQL, but most of them are MongoDB based. Yeah. Even though I work with SQL as my day job. Third Decade says, "Oh hi, good to see you by the way." Can you elaborate more on insights? Do joins create them? And can you mention an example maybe you ran into in the past? Yeah, we're gonna do some examples today, and we'll see a little bit of what I'm talking about. Yeah, absolutely, Divine Fox. Feel free to check out really most of the projects on my YouTube are gonna have a MongoDB backend. So if you pick one at random, you're gonna learn some MongoDB. All right. If there's any more questions, feel free to ask. Otherwise, let's head on over to LeetCode and start up with some examples. Now, let's go solve some issues. Exactly, Petraja. Let's go do it. So we're going to head on over here to the SQL 50, which is the most common, or I guess what LeetCode considers to be the most valuable interview questions that you might encounter in an interview. And we've already done several of these last week. Um, so if you are just a complete beginner to SQL, you could always rewind to last week's stream, which is right here on my Twitch channel still. And you could check that out for more of a real beginner introduction. I also have several intro to SQL streams on my YouTube channel where we just start from brass tacks and talk about what SQL is, how to write basic queries, what those words mean, that kind of thing. Otherwise, the questions we're going to do today are a little bit more advanced. They're still beginner questions, but we're starting to work with joins. We're starting to work with more keywords, clauses, that type of thing. Hotbab says, do you do that like JavaScript or Vue? I use JavaScript and React for most of my projects. So for my full stack projects on my YouTube channel, you'll find I'm either using JavaScript or React or TypeScript a little bit, but mostly just straight up JavaScript or React. All right. So last week, I think we left off. Let me just check my notes here where we left off. Type exclamation point Leon, exclamation point Leon in chat. And that will give you a link to the 100 Devs Discord on which you will find me and many other lovely people. Yeah. So the second link there in the bot has just provided. The second link is the link to the Discord. Go check it out. It's a nice place. There's about 30,000 members on the Discord. Actually, maybe more now. Maybe 50,000. It's a good Discord. Yeah, no worries, Rex. Okay, so let's see. I think when we left off, we just did. Yeah, actually, we're gonna repeat one question. So we're gonna do one of the questions that we did last week. We're gonna kind of to get warmed up. We're gonna do that one again. So I want to do customers who visited but did not make any transactions. All right. So And just as an FYI, this isn't going to matter all that much most of the time, but I'm going to be using T-SQL, which is Microsoft's version of SQL. There's several versions of SQL out there, um, including Oracle, Postgres, and MySQL, but I'm going to be using MS SQL Server today, just as an FYI. Sometimes versions of SQL are slightly different from each other, but shouldn't matter too much. Okay, so let's take a look at this question. We have two tables, visits and transactions. So in the visits table, our columns are visit ID and customer ID. Now it's important to remember when you see a table definition like this, um, even though these fields here are written, vertically, one on top of the other, one on top of the other, what they're actually talking about is that these are the columns going across the top of our table. And then there's going to be multiple records for each visit and customer ID going down. So as you can see down here, this is what this table actually looks like down here in the test case. We have a column called visit ID and a column called customer ID. And visit ID is the column with unique values for the table. Now, does anybody remember what do we call the column with unique values in a table? The column has unique values in a table. What do we call that? It has a special name. It's unique. That's correct. Yeah, it's what we call a primary key. And it's called a primary key because it is the specific field or column that we can use to identify any unique record in that table. So if I wanted to um, access visit ID number 257, I know that if I queried for visit ID number 257, I would only get one single row back. So the primary key is only ever going to refer to one single row in our table. Never be duplicated. It is always unique. Okay, so that's what we mean when we say primary key. Our first table here contains information about the customers who visited the mall. Okay, then we have a second table here. It looks like this down below. So our transaction table contains three columns: transaction ID, visit ID, and amount. Now, here they're telling us that transaction ID is the primary key for our transactions table. So they have different primary keys, but that doesn't mean we're not going to be able to join them together. Hey, Orestes, good to see you. Good to have you back. Hope you're doing well. I'm doing great. So this second table here contains information about the transactions made during a particular visit. So if we think about this logically, during a particular visit, a customer could potentially make multiple transactions, right? They might make anywhere from 0 to a bunch of different transactions. So we could have 20 transaction IDs here for the same visit ID, right? And we can see an example right here. So for example, during visit ID 5, we have how many transactions? How many transactions were made during visit ID 5? Oh yeah, and if you're new to the stream, I ask you guys questions sometimes too. I'm not just gonna be talking the entire time. How many transactions were made during visit ID 5? Yeah, Renitz, you're right. It's well, several, that's true. So technically correct, the best kind of correct. Yes. So as Renit said, it's 3, right? Because during visit ID 5, transactions 2, 3, and 9 took place. We have 3 rows matching visit ID 5, right? So that means 3 transactions took place during that visit. Okay. So what do they want us to do? They want us to write a solution to find the IDs of the users who visited without making any transaction, and the number of times they made these types of visits. Return the results table sorted in any order. So just by reading this, what I'm reading here is that they're going to want us to not only join these two tables together somehow, but also to filter it in such a way that we are only returning the IDs of the users who did not make a single transaction. Okay? So essentially, we need the customer ID from the first table, and then we need to use the information in the second table to see whether a customer actually made a transaction during that visit. And if they didn't, that's when we want to return them. So for whoever was asking about where clauses earlier, we're going to get to use a where clause here. And they want to return the results table sorted in any order. And so here's an example of what they want. So for our input table here, we have our visits and we have our transactions. And then the output, based on the criteria that they asked for, only returns customer ID 54, 30, and 96. So let's look at those customer IDs and see what makes them unique. So customer ID 54, they are attached with visit ID 5. Okay, so now let's look at our transactions table. So what was unique about visit ID 5? Well, we already saw that there were 3 transactions made. There were 3 transactions made during their, I guess, visit to the mall, right? During visit ID 5. There were 3 transactions made. And customer with ID 54 visited them all 3 times, exactly as we said. Now, during 2 visits, they did not make any transactions. And during 1 visit, they made 3 transactions. Okay, so visit ID 5, they made 3 transactions, as we saw. However, they also visited the mall 2 more times. So visit ID 7 and visit ID 8. And if we look at the transaction table, there's no visit ID 7 or 8, right? So that's what we want to return in the output. All right, so for visit ID 7 and 8, there were no transactions. There's no matching, our join didn't find anything to match on here. So that's what we want to count. And the same with customer ID 30. So they had a visit ID of 4, and we can see that they made no transactions. There's no entries in the transaction table here. So they have a count of no transaction of 1, right? And the same with customer 96. Visit ID 6, there's no matching record here, so we want to return that with a count of 1. Okay. And as we can see, users with IDs 30 and 96 visited the mall 1 time without making any transactions, and user 54 visited the mall twice and did not make any. Okay, hope that makes sense so far. Now, let's see how we can put a query together to figure this out. This sounds complicated at first, right? There's a lot going on here, but we can build our query slowly and iterate. We can iterate on the query as we go and make it return exactly what we want. All right. So first thing I'm going to do is I'm going to decide what my base table should be. So out of these 2 tables, which do we think is the most important? Which of these 2 tables, visits or transactions? Which one should you think should be my base table? My table A, as it were. Yes. And I agree with that. Our base table should be visits. Yep, exactly. Our base table should be visits. So that's going to be our table A. And we're going to join transactions as our table B. Now, let's think about what join type we might want. What join type? So, and I'm going to make it easy on you. We're only going to, like I said before, really only consider 2 types of joins. Consider inner joins, consider left joins. So you don't have to answer yet if you're not sure. You can just think about, do we want to do an inner join here or do we want to do a left join? Renate says, when in doubt, try left join. And that's not a bad suggestion. Yeah. When you're not sure, probably the best thing to do is try left join and see what you get. And then you can always refine it and shrink your result set down by using an inner join if you need. So it seems like we got some momentum here for the left join. So let's go ahead and do that then. And Rex Racker says, do you recommend to always start from the from clause? What I would normally do if I'm kind of scoping out a new data source and figuring out how to work with it is I would actually do this. Select star from visits and select star from transactions. Now, what am I doing here? What am I doing here when I write these? What do these queries do? Yeah, we're getting all the things, right? First thing I'm doing when I scope out a new data source that I don't know is I would return everything from both tables. And this is not a join. We're not joining anything here. I'm just doing independent queries on both tables to see what's in them. So if you're asking where I would normally start, this is where I would start. I would do a select star and make sure that the data looks the way I expect before I start trying to hook it together. I can get a feel for what columns are in the table if I don't know. I can get a feel for if maybe there's some columns that are entirely null. So I'm not going to be able to join on them at all, right? That's not going to work. So it's important to understand your data first. But we're going to use visits as our base table. So generally, this is how I would start. Even if I know I'm going to be, selecting certain columns. I'm always just going to usually start with a select star. And then now let's go ahead and set up our join. And then after we have our join set up, then we can decide exactly which columns we need from which tables. But I generally do the join first. All right, so I'm going to say visits, and I'm going to label that as table 1. And we talked about this last week. What I'm doing here is I'm essentially giving this table a nickname or what we call an alias. So that anytime I want to reference a column from one of these two tables, I will identify it with table one or table two. And so that way the SQL engine knows exactly which table I'm talking about. So we'll see how this works in just a second if you've not seen this before. So we said we wanted a left join, and that's perfectly fine. So I'm going to say left join, and I'm going to left join transactions as table two. And you could say A and B too. That's perfectly fine. Whatever makes sense to you. This is how I learned to do it. And so we talked about this last week, but when you're aliasing tables, everybody has strong opinions about it, how they want to do it, or what's best. But generally, just do what is readable to you. So for me, it's table one, table two, but again, your choice. Now, as we talked about before, when we're talking about joins, we need to join on at least one criteria, right? We need to join on something. We need to tell the engine what to use from both tables in order to match the rows together for us. Okay? Making a skeleton of a future query. That's correct, Bactrazia. Yes, I always start with a skeleton and then I build on that skeleton to refine my query and make it what I want it to be. Exactly. All right, so let's figure out what we're going to join on. Just by looking at these two tables, at the definition of both of these tables, what should we be joining on? What field from table one, what field from table two should we pick to create a valid match on each row from table A, table B? Yeah, visit ID. Exactly. So just by looking at the definition of both of these tables, we can see that the commonality between the two is visit ID, right? It exists in both. It's the primary key in our base table. So that's perfect because that will give us essentially a thank you so much for the follow, Eagle 75 point. I like that name. The big font, 75 point. Yeah. Yes, so here we have the primary key in visits. So we're going to use that primary key to join to our transactions table on visit ID, which also exists there. Now, a little bit of a harder question. Does anybody remember when the primary key of another table exists in the table we're currently looking at, so in transactions, I know that visit ID is the primary key of visits. So if I was referring to this table in transactions, what would I call it? It has a name. If I'm saying, oh, this is the primary key of visits and it exists in the transaction table, what would I call that? Foreign key. Yes, exactly. That's called the foreign key. Sometimes you'll see it abbreviated as FK. So you'll see PK abbreviated as primary key abbreviated as PK and foreign key abbreviated as FK. And the reason that this exists in our transactions table is to allow us to join these two together. That's why it's there. And so that's called a foreign key because it's foreign to this table, but it is a key in this table. Divine says, does MS SQL support using instead of on? Not sure anymore. I know MySQL supports that syntax sugar. That's a good question. I don't know if we could use using here or not. Yeah, if somebody wants to Google that, post it in chat. Let us know. Does T-SQL or MS SQL support using instead of the on clause? I'm going to use on here today because that is it's a commonality across any flavor of SQL. Any version of SQL you use will support the on keyword. But there are other keywords out there that exists in certain flavors, but not others. Yeah, I actually don't use Microsoft SQL for my day job. I use Oracle SQL. So I'm trying to get better at MS SQL by doing these leak codes as well. So this is partially for me. All right. So on, we said visit ID, right? So I'm going to say T1 dot visit. Actually, I shouldn't be typing this. I'm going to copy and paste it. Otherwise, I will spell it wrong and then we'll all be in trouble. And then T2 dot visit ID. And what I've done here is I've used my alias. So I've used my alias to specifically say, hey, I want to grab the visit ID field from the visits table and the visit ID field from the transactions table. So this is just a shorthand or a nickname to refer to this table. Now I could do something like this instead. I could put the whole table name here if I wanted to, but I don't. So you'll find that some people do that, which is fine. I don't generally. I will always alias my tables in this way most of the time. Using in Microsoft SQL is not supported. Okay. Yeah, there's little variances like that. So I'm going to use, I'm going to use keywords that are common across most languages to make it easier for folks. Sometimes. Yeah, when I had to switch from Microsoft SQL to Oracle SQL to PL SQL, there were all sorts of little things that kept tripping me up. But in the end, it didn't take long to switch. All right, so this is our join, and that's set up perfectly. Great, awesome. Now we need to filter. We need to filter things down a little bit. So before we do that, let's see what this is going to get us. So what I'm going to do here is now I'm going to specify some specific columns. We're going to run a test query and make sure this is returning some of the data that we think it's going to. So I'm going to say select T1 dot customer ID. How did I type that out? I need to copy and paste instead. Select customer ID. Let's also select T2 dot, we'll do T2 dot transaction ID and visit ID. I don't really care about the amount. The question isn't asking for that, so I don't have to return it, so I'm not going to. T2. All right, let's just see what this gives us. It's going to tell us it's the wrong answer, and I'm expecting that because we aren't answering the question. We're just looking at data right now. Yeah, it's as Eternal said, it's better to use SQL standards than SQL keywords from specific dialects. Yes, yeah. Whenever you can, you should try to make it readable and usable across multiple flavors. You can't always do that. Sometimes there's very specific things you have to do in one or the other, but for the most part, don't get too embedded. No worries, Leo. I said I wasn't going to be streaming this weekend, and then here I go streaming. So it's not your fault at all, Leo. All right. So let's see what our output looks like. Now, it's highlighting this in red because it's wrong. It's not what the question is asking for, but I don't care because I want to see what's in here. All right. So what does our output look like? It's giving us all of our customer IDs, and as expected, you can see it's taken our customer ID from table 1 and it has spread it across all the matching records from table 2, right? Because in table 2, which was transactions, our customer ID 54 here, customer ID 54 was associated with visit 5, and visit 5 had 3 transactions. So those 3 transactions are right here. Customer ID 54 is matched on all 3 transactions and spread out to fulfill all 3 matches. Now, there were 2 other transactions, right? Customer ID was also, customer 54 was also responsible for transactions 7 and 8. However, as we talked about before, customer 54 doesn't have any records in our transactions table, so nothing matched. So both of these fields from table 2, transaction ID and visit ID, are both null. But the records from our visits table were still returned because we are doing a left join, and that is our base table, right? So if we're looking at left joins, our visits table was table A, and so it's going to return all the records from table A, regardless of whether or not they have a match in table B inside of our transactions table. Okay? So that's why these are here, even though the T2 records are null. Oh, sorry, I missed a question. Sorry about that. If you use select star when joining 2 tables, will it return everything from both tables? So by default, select star will return all columns, but generally you want to not do that in most cases. Thank you for the follow, Cudiastro. You're generally going to do something like this, where you're specifying a select number of columns from both tables. And then you're going to filter the rows, correct? As D-Rock said, you're going to filter the rows. So you're filtering columns using your select statement. Then you're filtering rows using your where clause. So that's how you get your subset of data. Yeah. So we can try that if we want. Just real quick, let's do this. Yeah. So you can see when I do that, I get all the columns from both tables. But I don't care about all these columns, so I actually only want a subset. So this is the better query to run. Okay. Now, so this data is looking the way I expect. So now let's figure out what kind of where clause we're going to need. Yeah, it also runs it. Yes, exactly. That's a great point. Thing to bring up. If you can avoid doing a select star when you know you only want like a certain subset of the data, you should try to only specify the columns that you need rather than everything. Because when you get into larger tables in like an enterprise system or like in a corporate database, you're going to have tables that have many millions of rows and maybe like hundreds of columns. You can get into hundreds of columns in a production database. And so instead of doing a select star on that, you're going to want to do only select the columns that you need and definitely apply a where clause of some kind. Yep. The DBA, that way the DBA won't come hunt you down like she did me that one time. All right. So let's figure out our where clause next. So what does this question actually care about? They want to find the IDs of the users who visited without making any transaction. So that is going to inform our where clause. So I write my where clause, and these do have to be in a specific order. My where clause goes after the join. So if I want to find the IDs of only the IDs of the users who visited without making any transactions, first off, what field am I going to be filtering on? Let's start with that. What field am I going to be filtering on? Which field in the table be filtering on? Yeah, we're going to be filtering on transaction ID, aren't we? Yes. So we're going to say where, and then it's going to be, this is in table 2, so T2 dot transaction ID. Now, what do we want to find about transaction ID? Well, if a user didn't make any transactions, which we can see here, so for example, customer ID 54 didn't make any transactions in 2 of their visits. So they didn't make any transactions in 2 of their visits. So those values are null, right? So I think what I want to do is I want to only return the records where that transaction ID from table 2 is null. And so the way I can do that, there's a quick shorthand there. I just say the words is and null like that. Okay. And I'm actually going to do one more thing here. I'm going to add one thing to my query just to make it a little clearer. I'm going to say t1.visitID and then T2. So T1 customer ID, T1 visit ID, T2 transaction ID, and T2 visit ID. This should show those nulls very clearly when I run it again. Run. Gonna get closer here, I think. Yes, we are. Great. So now, customer ID on visit 4, they didn't make any transactions. Customer 96 on visit 6, they didn't make any transactions. And customer ID 54 on visits 7 and 8, they also didn't make any transactions. If we look at the example that they gave us, this is essentially what they're wanting, right? We can see that our counts are correct. So 2 records here with no transactions equals a count of 2, and then 1 each for these 2 customers as well. So not only are our customer IDs correct, looks like our record counts are correct also. So we're getting closer, aren't we? Getting there. Getting warmer. All right, now the final step is going to be refining this data a little bit. This is where we get into more like the analytics part of things. So now we have the raw data we need. So how do we use our data analytics brains to refine it to the point where we get the only the counts. I don't care about really this stuff. I don't care about what visit ID it happened on. I just want the count of visits where there were no transactions. So let's figure out how to do that. Yosef says the litmus test of SQL dev is you can write a CTE without looking at docs. Yeah, there's a really good developer on our team who does CTEs just like off the top of his head all the time, and I'm just like, man, he's so good. He's so good. He's so good at it. His brain is like he's way better than I am at coming up with complex queries. It's great. I love having people to learn from um, on my team. I love having people who are just good at stuff, who are better than me at stuff on my team because that's fun to learn from them. I'm not one of those people who can write CTs off the top of their head. I always have to look. Yeah, and it's hot. Bab says we could use count, right? Yeah, we're gonna have to count these transactions, right? So somehow we're gonna have to turn this select statement into a count instead. Yeah. And so this is gonna bring us to a very useful keyword called count. They're literally telling us what to do in the question. Basically, they're saying um, number of times, and so they're telling us to call the field count no transactions. So we can use the count keyword to get what we want here. Hey, Zyrazine, welcome. You're preparing for your college exam. This stream is helpful for you. Oh, that's awesome. That's great that you're learning SQL in college. That will be really helpful for you. I wish I had been able to learn SQL in college. I didn't have that opportunity, unfortunately. Um, I wish I'd been able to learn it a little sooner than I did. All right, so let's figure out how we can use the count keyword to get the data that we want. So let's first get rid of some of the columns that we don't need. So we don't care about visit ID. They're not asking for it. So I'm going to get rid of it. Boop, boop. There we go. I'm going to winnow it down to just these two, customer ID and transaction ID. Now, if I want to count something, could I say, return customer ID and then the count of transaction IDs from table 2? Could I do that? Will that work? If I try to count the transaction IDs from table 2, will that work? Take a look at the result here and let me know. What do you think? These two fields are from table 1. Remember, these two fields are from table 1, and these two are from table 2. So if I try to count the transaction IDs from table 2, will that work? Try to count these values here. Will that work? Why or why not? Hmm. It won't with null. Yeah. Right. So I can't count the transaction IDs from table 2 because they are all null. And what does null mean? I realize that some folks out there might not know what null is. So what is null? What does that mean? When I say null, what does that signify? Because I mean, it's shown here as a thing, right? It's a word, but it's not actually the word null. It signifies something else. What does it mean? Ah, no value. It doesn't exist. So the best description I ever heard for how to describe null is think of in a bathroom you've got like a toilet paper holder, right? You've got a roll of toilet paper on on a rod usually in your restroom, and you've got like roll of toilet paper on there. Now when the roll is full, like when there's toilet paper on the roll, that means there's a value there. There's something there, and then when you've used up all the toilet paper and it's just the cardboard tube left over, then you've got basically like something like 0 or an empty string, right? It signifies nothing, but there's still something there. There's an empty string or there's a 0. There's a value in that field, right? There's something there. That record has a value. It's signifying empty, but there is still data there. Now, if I were to then take the cardboard tube off of the toilet paper holder completely, leaving just the empty rod, then that's null. There is literally nothing there, no data. So it's important to remember the distinction between something like 0 or an empty string, like a blank. versus null. Those are two different things. One of them is data that means no, like that means empty or zero. And then null means there is literally no data in that record. So we can't count it because there is no data there to count. Okay? A value that signifies no value. Yeah, it's something like zero or an empty string is a value that signifies no value. Exactly. All right. So we can't count transaction ID. Instead, what I'm going to count instead is I'm going to count customer ID. And I'll talk about why I'm doing that in just a second. First, I'm going to write it out for you. So I'm going to do this. So yes, I am using the same field twice, but that's okay. And I'm going to give it the name that they told me to give it, which is count no transactions. Blockerator, thank you. Welcome to the stream. I'm glad you arrived just in time for my toilet paper analogy. Yes, only the most quality content for my new viewers. All right. So what am I doing here? Oh, I shouldn't have a comma there. Sorry. Take that away. All right. So this will return the actual customer ID, just like we see here. However, when I say count, this will return the numeric count of the number of times it encounters the same customer ID. So for customer 54, it's going to say 1, 2. So my final count will be 2. It's going to increment that counter by 1 every time it encounters the same ID. Now, why am I counting on customer ID? Well, because I know it's always going to be populated. It will always have a valid value that I'm going to be able to count. And why do I always know it's going to have a valid value that I can count? There's always going to be something in there. There's never going to be any nulls because inside of our visits table, each visit has a customer ID associated with it. Glad you liked it, Drunk Grandma. We already saw that since we're doing a left join, table A is our base table. Every visit has a customer associated with it. So I'm going to count it. I could also count visit ID. That might even be a better thing to count because it's the primary key. But I already know this is going to work. So I'm going to call it count number of transactions and then from visits. Actually, no, customer ID is the better choice because I'm grouping by customer ID. So I should be counting customer ID as well. Yeah. So that is the better choice. So I'm selecting that from visits. Okay, great. Now, if I were to try to run this right now, it's not going to work. But I want to show you the error that you get because this is a common thing. So people who are new to SQL, you will do this. And people who have been using SQL for a long time, you will do this. And so you should learn to recognize the error and what it means. So I'm going to run this. It's going to error out. I'm going to show you. Yep, we got an error, baby. All right, so what does it say? Let's read the error. Visits.customer ID is invalid in the select list because it is not contained in either an aggregate function or the group by clause. Aha. So this error has a lot going on with it, but the most common thing that people forget when they're doing counts is the group by clause, just like that. So if we are trying to count things and put them in specific buckets, so in this particular query, we're specifying that customer ID is our bucket, and we're counting the number of rows that go in that customer ID bucket. So from the previous example, we know that there are 2 matching rows with that customer ID, so they should go in the customer 54 bucket. Boop. So customer ID 54 should get 2 things in its bucket. But we have to tell the SQL engine what buckets we want to use, what groupings we want to put things in. In this case, we want to group by customer ID. Those are our buckets that we're putting the matching records in. Okay? All right, so now let's run this and let's see what we get. Yeah, this you always get wrong. Yeah. It's a little funky to think about at first, but I like to think I like to visualize buckets in my mind. What bucket in my result set? What buckets do I want to see? And so in this case, the buckets that I want to see are customer ID, and I want to see a certain number of things in each bucket. I want to see a count in each bucket of the number of matching rows. Now, you might have a different way of visualizing it, but that's just how I do it. So if you think of something better, then by all means. However, if we look at our output, it looks to be correct. So we can see that for customer 54, we have 2 transactions. For customer 30, we have 1. And for customer 96, we also have 1. Now, you'll notice that they're in a different order than in the example, and that's okay. The way the SQL engine works is it's going to just return the rows in, we didn't tell it to order by anything, so it's just going to return the rows in whatever order it wants. It doesn't care. And the question doesn't care either. They have told us explicitly that we can return our results table sorted in any order. We could order it if we wanted to. We could say order by, count transactions, whatever. But in this case, we don't have to. The question's not asking. Okay. Hopefully that makes sense. So in the end, this is our finished query. It gives us what we want. And Petrazio says, could all this happen with another join type? Potentially, potentially, I'm going to say that if you filtered it the right way, maybe. But it really, the left join is the correct one to use because it's gonna fulfill the criteria that we're asking for. It's going to allow us to count the number of non-matching records in the other table, so the records where we have a null value. And the most important thing it's going to do is it's going to do what we call blowing out the records in the first table. So for our visits table here, if you recall, we only have essentially one record per visit ID, right? One record per visit ID. That's the primary key. But in table two, we have multiple transactions per visit. And that's what this question is asking for. It's asking at the transaction level, give me information about the customer, right? So we need to what we call blow out or expand the rows in the visits table with the matching customer ID to help us count at the transaction level what's going on. So really we need to do this. Well, I guess the most prudent way to do this would be with a left join. And there's lots of ways you can finagle things to force other join types to work using filters and stuff, but why would we do that when we have a join type that is going to work perfectly for our needs? Thank you for the follow. Oh, sorry, I didn't get your name. Nifine, thank you so much for the follow. And Kudiastro, I apologize, I missed you. Kudiastro, thank you for the follow, and Nifine as well. No worries, Hot Bab. Feel free to watch the go to bed if you need to, do whatever you got to do. You can always watch the VOD later. These are all recorded, and eventually you'll find them on my YouTube channel as well. You can follow me on Twitter, which is @MayanWolf. I always announce when I'm moving new stuff to YouTube, so feel free to check that out as well. Rex Record says, "How about the records not in where both tables intersect?" Yeah, so if we look at our little graph here, you can do that. You would do that with a full outer join, which is not something you'll do very commonly. I would probably only use a full outer join in this capacity if I was like doing some kind of validation. Like if I was wanting to make sure that I didn't have like orphan fields in table A or table B, if I was validating a data set, I'd be like, hey, is my data fully complete in both tables? Do I have exact matches everywhere? Then I would use this type of join to say, hey, do I get any results here? Like in this area, do I get any results? If I do, then there's something wrong with my data. So that's probably how I would use that. Yeah, as Fuel Snabble said, it's full outer join. Exactly. It's a full outer join with specific criteria. No worries, Hobab. Good to see you. 21, welcome. So just completed your React tutorial after a long break. Oh, nice. That was a lot of fun. We'll be refactoring old projects with what I've learned. Haven't touched SQL yet, but looking forward to catching up on the VOD. Thank you for everything. Yeah, no worries. I've got several intro to SQL, like just bare bones starter intro to SQL videos that explain what SQL is and what these words mean. And it's a little less, daunting than maybe some of this stuff might be if you're a total beginner. So go to my YouTube channel, exclamation point YouTube in chat, and just search for the word SQL, and you'll find several intro to SQL streams that I have there. And if you are interested in my React tutorial, we go through all of the modern React documentation. We go through all of the examples. We talk through it in very relaxed terms. We go very slowly. We go through every example. We do them together. We explain what's going on. Head over to my YouTube channel and search for Intro to Modern React. Yeah, Intro to Modern React. There's 7 parts, I believe, to that. So you'll find 7 videos there that match that. 1, 2, 3, 4, 5, 6, 7. And so yeah, it was quite a ride. We spent several months on it. And want to really understand React, that's what I would recommend. Yeah, no worries. Just now says I'm waiting for the sequel to the sequel tutorial. Yes. Yeah, and we have also too, after you finish with the React tutorial, we do follow-up projects. So we actually then use that knowledge, that React knowledge, to build stuff. We've done several React projects here on stream, some of them more complicated than others. But yeah, we definitely then use that knowledge to actually build projects, which that's how you actually take that knowledge and put it in your brain and make sure it stays there. So that's very important, is after you finish the tutorial, then you need to go build something. So we've done that several times. Yep, exactly. Very important. Okay, so I'm going to submit this, and then we're going to take a break because we are overdue for a break. Let's see. Oh, what did I do here? Did I miss something? Let me double check. I think I did what the question asked for. See, visit ID, transaction ID. But let's see what test case we failed here. No transactions. Okay. Will transactions output customer ID. Oh, okay. Interesting. So they're saying it should be 3 there. However, I believe this was the same example that we looked at in the test case. 23, 9, 30, 54, 96, 54. Yeah, so that's the exact. Oh, no, it's not quite the same. So then we have one with an amount of null. Ah, they threw in a curveball there. Okay. So amount of null on the visit ID. So there is one null transaction. So this is actually a very easy fix. We just need to add one more criteria to our little query. So I guess and this is something that the question didn't quite specify, but that's okay. We can refine this. So I guess if a transaction ID exists, but the amount is null, they're counting that as not a valid transaction, or are they? Let's see. Expected. Count transaction is 3. Oh, okay. So transaction, we have 3 there. And then, oh, okay, so 3 there and then null. All right. Well, let's go ahead and take a break. And then when we come back, we'll finalize this question. But I need a break for hydration reasons. I am out of drinkable liquid. So when we come back, we'll finish this question and then we'll move on to the next one. It's not a correct question then transaction. Yeah, it is a little weird, but we'll figure it out. It's all good. Pet the dog while I absolutely will. And I hope that anybody else that has pets is gonna get up, get some hydration, use the bathroom if you need to, and pet your dogs, pet your significant others, all those types of things. All right, take a quick break and then we'll come back and we'll finish this out. Do a little refinement. All right, be right back. Okay, folks, we've got about a minute left in the break, a little bit less now because I was slow on the mute button. But come on back if you're coming back. We have the solution to the problem. I've tested it and it works. It's a very easy fix and something that happens quite a bit. So I'm eager to show you how we can navigate this particular solution. So get yourself a glass of water if you need one. Get up and stretch if you've been sitting this entire time. Pet your dogs, pet your cats, pet your significant other with their permission, of course. And then come on back to hear what the solution is to the problem. All right, folks, welcome back. Good to see you all again. Okay, so this is a very easy fix, and I was a little confused as to why the particular solution we just didn't work, and so I looked at the forum, and they said that this question had been changed on like December 1st. So like this solution literally worked last week when we did it, and then now this week it has stopped working because they changed the question in between last week and this week. So that's okay. Sometimes that happens. Data is weird. Sometimes you're going to get changes that you don't expect, and so that's all right. Um, so as we saw in the test case, I wish I still had that pulled. Let's see. I yeah, it's not going to show me the table. That's all right. So in the test case that we failed, it failed because there was a valid transaction ID in table 2, but there was not a valid amount, right? The amount was null, but there was a transaction ID. So apparently, even though the question doesn't specify, what they're specifying is if there is no amount, then it shouldn't be counted as a transaction. So even though they say, without making any transactions, what they actually mean by transaction is there's no amount. Is there an amount? So really the only thing we need to do here is change the reference point from transaction to amount. So T2 amount, they change the wording of the question. Hopefully they will change the wording of the question to be more specific, but now we'll run this. And it's going to do essentially the same thing, except instead of looking at transaction IDs, it's going to look at amount values. And so when we go ahead and submit this, we shall see that it works. Hooray, we did it. And as Petrazio said, this is not a correct question then, a transaction of nothing. Yeah, the thing about data, and this is why I always do like select stars against my tables before I try to write a query against it. I will always do a select star because the data isn't always going to make sense. Unfortunately, something you'll encounter quite a lot, especially in like enterprise data, is that it's going to suck sometimes. You're going to have things that are supposed to be populated that just aren't. That are or that are sometimes populated and sometimes not. You're going to get bad data, and so unfortunately with leak codes you can't do like a select star and get all the test cases to see what they're going to test you on. But with real like enterprise corporate data, again, the first thing I always do when I encounter a new table that I've not seen before is I will do a select star on it to see what kind of weirdness it's got going on, because you're going to get some fields. You'll look at a table definition and you'll be like, oh yes, that's exactly the field I need. It looks exactly like the description of that field. The column name is exactly what I need for my query. And then you run a select star on the table and it's null, it's empty, like nothing, it was never populated. And you're like, well, dang it, I guess that isn't what I need. But I didn't, waste half an hour writing a query on it, right? Second try, yeah. Yeah, they pulled a fast one there. They changed the question on December 1st, which was 2 days ago. So that's pretty funny. All right, next question. Let's go. Oh, any remaining questions on this before we move on? Feel free to ask. Have anything? Okay. Again, feel free to ask questions at any point as you have them. So I think the next one, next. All right. Let's do, I'm going to think about the next one I want to do here. Let's do another let's practice aggregation a little bit more. Um, I want to do number of unique subjects taught by each teacher. So I know some folks are a little uncertain about the group, how we what we're doing when we're grouping things, what that looks like, how that feels. So let's do another grouping question. All right. So here we have a single table. So we're not going to do a join here. Um, but that isn't always the case when you have a single table. And the next question we're going to do is an example of that. You can still do joins even if you have only one table. But anyway, in this case, we have a single table called teacher. It has 3 columns: teacher ID, subject ID, and department ID. And here they're telling us that subject ID and department ID are the primary key or the combination of columns with unique values of this table. So here's something to touch on is that primary key doesn't always have to be a single column. It can sometimes be multiple columns that work together to create a unique reference. So by combining the subject ID and department ID columns together, I can always reference a single row. So if we look at it, we can see what they mean here. So here we can tell that teacher ID is most definitely not unique, right? We've got repeats all over the place. So that's not a unique value. Now, subject ID is also not unique, but I mean, it's a little closer. And department ID is also not unique. We have repeats here too. But if we wanted to define a primary key for this table or a unique reference for every single row, we can get that by combining the subject ID and the department ID. So the combination of these two values is always going to be unique for every single row in the table. So just remember that primary key doesn't always have to be a single column. It can be a combination of multiple columns. And that's the kind of thing you define when you create the table itself. So when you do your initial create table statement to build this table, for starters, you will define what you want the primary key to be, whether it's a single column, multiple columns, whatever. Petrozzo says true, but should we check this manually by looking at each value? No. We could always do a select star. But I can see just by looking at this that I don't see any duplicates between, looking at each of these rows. I don't see any duplicates here that are going to violate this. And um, they're telling us specifically that that is the primary key. Um, so I'm going to believe them here. Now, we know that some of the test cases might be a little wonky, as we saw in the last question. But we have no way to check that, unfortunately, within LeetCode. Like LeetCode hides the other test cases, so we can't look at those. Oh, and thank you for the follow, Archie Prince 77. Thank you. Good to have you here. Now, Petrazio, if you were looking at a real table in like a production database, let's say, um, if something is defined as the primary key in like a real production database, um, the engine will not let you insert values into that table that don't meet the requirements of the primary key. It will physically stop you from doing that. So once you define a primary key, so if I was creating this table and I said I want subject ID and department ID to be my primary key, if I tried to insert another record that say has values of 2 for subject ID and value of 3 for department ID, it will physically not let me do that. I will get an error. Or if an automated process is doing that, then it will error out. Charlie said, no, I meant the combo primary key. Will the engine take care of this as well? I'm not quite sure what you're asking me there. Are you asking if it's valid to if there were repeat values here, would it stop us from setting the primary key as these two values? Make sure I understand. Because it's most SQL engines are they're going to be very strict about primary key validations. So if you're trying to do something that isn't valid for signing a primary key or for inserting a record that violates the primary key, you're gonna get an error. It's gonna not like that. It's gonna say, nope, you're not allowed to do this. Okay, so let's start forming this query. So what do they want? They want us to write a solution to calculate the number of unique subjects each teacher teaches in the university. So I see a few identifying factors here. They want a count of some kind, the count of unique subjects, right? That each teacher teaches in the university. So I'm going to need to do a count, right? And what's the second component of every single count? So I define a count. And then what's the second part of count? Two things I need. I say the thing I want to count, and then what's the second part? Yeah, exactly, D-Rox. That's what I was saying. If I try to insert a record that if I try to insert another record that has a subject ID of 2 and a department ID of 3, if I try to do that, I will get an error. The engine will error out. It will not let me. Yep. So if I'm clearly going to need to do a count here of some kind, right? So I can say, select count, whatever. What else do I need if I want to write a count in a SQL query? What's the second part? There's two parts that go into making a count. Anybody remember from the last? I said it's the thing that most people who are new to SQL that they often forget when they're trying to do a count. Yeah, it's the group by, exactly. So we're going to count the number of unique subjects, right? But what's going to be our group by? What are we going to group by? What's our buckets that we're going to be putting stuff in? What are we grouping by based on the wording of this question? We want the number of unique subjects, but what are we using to create those buckets? The number of unique subjects. Write a solution to calculate the number of unique subjects each teacher teaches in the university. We want to know. Yes, it's the teachers, right? So our group by is going to be teachers. We are going to be counting subjects and grouping by teachers to see how many subjects each teacher is teaching. So we can see that here in the output. For teacher ID 1, that's our first bucket, they are teaching 2 subjects. And teacher ID 2 is teaching 4 subjects. Okay? And now the other ticker, the other important component here is, thank you for the follow, Dictator. Thank you for the follow. We want to calculate the number of unique subjects. So this is another thing. We'll get to that in a second. Let's tackle the basic question first. Number of subjects each teacher teaches in the university. We'll figure that out first, and then we'll figure out what they mean by unique. Okay. All right. So they want in the output, what do they want? They want teacher ID and then a new field called count. And there was a question here I wanted to answer that I missed earlier. Drunk Uncle Grandma says, how often do you come across databases like this where 2 columns together result in a primary key? Often. Um, I do it a lot myself, actually, at work. I build tables with, 3 or 4 columns that make a primary key together. Because again, a lot of the times you're going to encounter imprecise or dirty data, data that is not good. And so you need to combine multiple columns together to get enough information to create a unique reference. So yeah, it's often that I encounter that, actually. All right, so they want to return. We'll start out with a select star. So select star, and then from what's our table called? It's called teacher. All right. Now, I want to return teacher ID. And then I'm going to have some kind of a calculation, which is going to give me my second field, count. So it's going to be something as count. So essentially, we want to count subject ID, right? We already said that. So count of subject ID. And then they want that called count, like that. And that's coming from teacher. And then we already said we want to group by our teacher ID. That. Okay, so this is we're going to run this and it's going to be wrong, but we're going to look at what else we need to do to make it right. So this is an example of that kind of, we iterate queries. We run them first, we see what we get, and then we refine them with more criteria as we go. So let's see what this gives us. And then we'll compare it against the example to see what else we need to do. All right. Oh, thank you for the follow. Uh, Aaron, Aaron Kantrowitz, thank you. And Ayubio, thank you so much. Thank you both for the follows. Got a lot of new followers today. I love that. I hope y'all are having a good day. Welcome to the stream. Stick around. Okay, so what do we have here? Well, our output is close, right? But it's not correct. So teacher ID 1 shows a count of 3. Teacher ID 2 shows a count of 4. What they're expecting is that teacher ID 1 should have a count of 2. So we have some extra stuff in there that we don't want. All right. So now I'm going to take this count off and we're just going to see what this looks like. What else do we need to remove? So I can comment out this last line as well. We're going to get just a fuller look at the data. Okay, so we can see that teacher 1 does have 3 records here. So that was technically correct, but it's not what they want. And we can see it's not what they want because the subjects that the teacher is teaching, there's a duplicate here, right? We have 2 subject 2 values for teacher 1. And they're specifically asking, what is the number of unique subjects? So no repeats. They're essentially saying, give me the counts with no repeats. Count the subjects, but if there's a duplicate, if there's 2 subject 2s, that's only going to count as 1 record because this row is a duplicate of this row. Okay? Now for teacher 2, we got the right answer there because these are all unique. So 4 unique records, that's exactly what they wanted. However, for teacher 1, we need to get rid of any duplicates. Ah, yeah. First time chatters coming in. I love when first time chatters come in with a great answer. Yes, we're going to need to add an additional keyword here. So I'm going to put this back the way it was, like that. And I need to add in an additional keyword to tell the engine to only consider unique values. And the specific keyword that we use to do that is, as Dictator said, is distinct. I add this keyword inside of my count function here. And what this is telling the engine is, hey, look at all the records that match here and only consider the ones that are unique or distinct. So distinct is just another word for unique. And so this keyword says, hey, only get me the ones that don't have any duplicates, or essentially get me the first matching record and discard any duplicates, really, and then count those. And then only give me that. So let's run this now again. So the distinct keyword is really valuable when you have potential duplicates in your data set and you want to get rid of them. And now that we've done that, we can see that our output matches what's expected. Okay, so we didn't have to do another group by, we didn't have to do anything like that because there is already a built-in keyword, and this keyword exists across, as far as I know, across every single flavor of SQL, that allows us to only count the unique matching record. Okay, so does that make sense what we did here? If it doesn't, you're allowed to say so. You're allowed to say, hey, I don't understand. Can you explain it again? And I'm happy to do that. Otherwise, I'll try submitting this and we'll see if they decide to throw us another curveball like they did the previous question. I don't know, they might. Everything's up in the air now. So hey, there we go. Perfect. We got it. Go us. Yes, so this worked correctly. It's pretty succinct, pretty precise. And the distinct keyword can be really powerful. When you're using it, you just need to make sure that when you're using distinct, you want to make sure that you're paying attention to hey, do I actually want to keep duplicates or do I want to get rid of them, right? In this case, we very clearly, they told us to get rid of any duplicates, so we got rid of them. But you always want to make sure you're only using distinct when you truly want to discard, you know, repeated values. Okay. Any questions on this? Okay. Let's go on to the next one then. Short and sweet, right? All right, let's see. Which one do we want to do next? I want to do, I just have some notes saying what's in question, like what topics are, or what concepts are look at today. So I'm going to decide. Let's do, ooh, okay. I want to do, yeah, this is the one I want to do because it's interesting. We'll do this one. I think we, and this is another one we looked at last time, but we didn't spend a lot of time on it because we were out of time. So I want to do it again, spend some more time on it this time and explain what's going on a little bit better. So they give us a single table here called weather. And we have three columns in it. We've got ID, we've got record date, and we've got temperature. ID is our primary key. And this table contains information about the temperature on a certain day. So each record corresponds to one day, right? And we can see that by looking at the test case down here. So each record corresponds to a specific day. Now, they want us to write a solution to find all dates ID with higher temperatures compared to the previous date or yesterday. So, to rephrase this a little bit, what they're saying is we want to return all the IDs, so this field here, where there is a higher temperature than the previous day. So only looking at the at one day prior, is this temperature higher than yesterday? So for example, here on the 4th, the temperature is 30, but on the 3rd, it was 20. So we would return ID 4, and we can see that's the case in the result set here. Now, if I look at ID 3, the temperature is 20 on the 3rd, and then on the 2nd, it is 25. So the previous temperature was higher. We don't want to return that record. And let's look at ID 2. On the 2nd, the temperature was 25. And then on the 1st, it was 10. So we do want to return ID of 2. And then there's nothing prior to the 1st. And so that record has nothing to compare against. So we shouldn't return that record either. Okay, so in the end result, we're only going to return IDs 2 and 4. Okay, cool. So how can we do this? This gets a little interesting, right? Because we're trying to compare two rows in the same table against each other, right? Trying to compare two rows, each row with the row next to it. So how could we possibly do that? Because if I just did like a straight up select query, if I just did a straight up select query, by default, it's going to look at only, it's going to essentially only look within one row at a time. But what I want to do is essentially look at this row and this row, or this row and this row. So any ideas on how I might be able to do that? And I'll give you a hint. It's something we've already talked about. This is not something new. This is a concept we've already covered today. So with that in mind, anybody have any ideas about how we might be able to do this? And you don't have to give me specifics, just a general, hey, this might work type of. Think about this and think about what's a way that we might be able to do this. Here, let's start out. I'll help out a little bit here because yeah, this one's a little harder. This is a little bit this we're getting into a little bit different way of thinking. So first off, select star from weather. And I'm also really only want to return ID. So I'm just going to go ahead and refine this to say, hey, select ID from weather. Oh, and actually, is that capitalized? No, it's not. So select ID from weather. And, oh, got that already. Cool. All right. And so let's think about conceptually, maybe let's think about what my where clause might look like. So I want to figure something out. I essentially want to say, I want to limit my checks to only dates that are next to each other, right? So essentially, I only want to look at dates that are next to each other. I don't want to, compare the first against the fourth or the third. I only want to compare the first against the second, second against the third against the fourth. So that should tell us that we need some kind of a where clause. We want to limit this in some way. Um, okay. So I need to only consider dates that are within 1 day of each other, right? Essentially, that's what we're saying. Evolve into me. Thank you so much for the follow. So I only want to consider dates that are 1 day apart. Oh, the masters, what? The master smooth, the master smooth. Thank you for the follow. Your name went off the edge of my screen there a little bit. So so essentially in plain English, it would be where we're only 1 day apart. And as Petrazio says, do we want to do something like with date minus one somehow? Yeah, essentially that's it. We want to say day where this where this minus this equals 1 day. There's a way we can do that. There's a function we can use called date diff. It finds the difference between two dates and it knows how to read dates. So, because we've got, this is kind of some funky formatting here, right? But we can use this function. It knows how to read dates. It knows how dates look, how dates are stored in the database, and it knows what those different parts of the dates are. So it knows what a year is, it knows what a month is, it knows what a day is. And so if we say, I want to find two things that are 1 day apart, then it knows, hey, I need to look at not this, whoops, but this. And it will look at this element and will say, oh, you only want to compare things that are 1 day apart. So that's going to be in our where clause. We're essentially going to say where the days, where the difference between value 1, value 2 equals 1, only 1 day. Okay. And what's the second criteria in our where clause based on what this question actually wants? Write a solution to find all dates IDs with higher temperatures compared to the previous date. So what's the second part of my where clause going to be? So we already figured out this part, the yesterday part, just in general terms. What's the second part of my where clause need to be? You don't have to put it in symbols. You can say it in words, in English. What's the second part of my where clause? Two things they're asking for. We've done this part, the yesterday part, but they only want to see IDs where what? Yeah, exactly, with a higher temperature, right? So my where clause is going to have two parts. It's going to say, all right, only look at yesterday and only return values with a higher temperature. So that's going to be my where clause. But we still haven't necessarily answered the first question, which is how do I do that? How do I compare two records in the same table? Well, as a nifty little trick, we can do this. Actually, this down. Weather T1, weather T2. So remember how I said earlier that you can sometimes work with the same table more than once? And that's what we're going to do here. We're going to essentially select from the same table twice, but our where clause is going to control how that works. And I'm going to type this out and then I'll explain what it's doing because it's kind of new. So we're going to use date diff and we're going to say, hey, I want to look at days. And I only want to return records where the date is greater than the prior record by 1 day. And the temperature, they want the temperature in they wanted the temperature in this day. So the temperature, okay, this one here, to be greater than the prior days. All right, so let's look through this. We're returning IDs and we're doing a select on the weather table twice. But what we're doing is we're saying, all right, here are my criteria. Look at days only. So from record date, only look at this part of the field. And only return records where the difference between, or sorry, only look at records where the difference between the two is 1 day. So it's going to go down through the table and it's going to say, okay, well, I'm only going to do comparisons on this one and this one, this one and this one, and this one and this one. And then now that it's identified exactly what we want to look at, we're going to say, all right, now get me the temperature and check and see if the temperature value is greater than the one prior. Okay? So we're doing two things here. First, we're triangulating the records we want to compare. And the second is we're saying, okay, now only return the ones where 30 is greater than 20 or 25 is greater than 10. And that equates to 4 and 2. And the last thing I need to do here is I need to specify that the ID value I want to return is from T1. So if T1.temperature 30 is greater than T2.temperature 20, then return an ID value of 4 from T1. Okay? So I know that's kind of wild, a little weird, but really doing joins or doing multi-selects like this is the only way that you can compare across rows in a single table. Otherwise, it's just going to treat an individual calculation. If you want to do a calculation across multiple rows at once, which sometimes you have to do, then you're going to have to do something like this. We'll look at another example later, hopefully, if we have time, where you can actually then also, join a table against itself. Actually, we should do one of those next to get more practice, because this is a weird concept to just like get in your brain box. So let's do another one that's also similar to that same philosophy. Find a good one here. Yeah, we'll do, actually, it's the next one up. So let's go ahead and do that. So this is more about just introducing, we're introducing date diff here. So you can do date specific calculations, which is what we see here. And you can do calculations on specific parts of a date as well. So here we're specifying we want to do it on the day, but you can do calculations against months. You can do calculations against years, really any part of a date that SQL recognizes. Okay. So let's do the next one is going to be average time of process per machine. And this is going to follow a similar philosophy, so we're going to get some more practice here. I know this query looks a little longer, but it's really not that scary. There's just some more criteria on our comparison. All right, so average time of process per machine. So they give us a single table here called activity. Oh, I'm sorry, did I not? So I went back to the previous example. Guess I didn't run it. Yeah. So that looks good. Yep, and it works. Yeah. They didn't throw any curveballs at me this time. But you never know. I'm glad you caught me on that. So they're giving us a single table. In this question, they're giving us a single table here called activity. And the columns are machine ID, process ID, activity type, and timestamp. So real quick, let's just talk about data types. So machine ID here is an integer. So integer just means a whole number, right? Means a whole number, no decimal points. Process ID is also an integer. Activity type is an enum. Activity type is an enum. Now, if you're familiar with TypeScript, you might know what an enum is, but does anybody know what is an enum? What does that mean? What's an enum signify? Data types. I think that, yeah, this because yeah, this exists in TypeScript too. And it exists in most languages actually, enums too. So if you're going to learn any type specific language like I don't know, C# or something, then you're going to have to know what enums are. Special, okay, but what makes it special? Why? Hey, Master, said, are you using T-SQL? Yes, I am. You probably spotted that in the date diff function because it is slightly different depending what dates are slightly different depending on what flavor of SQL, especially Oracle. Does anybody know what is special about enums? Why are they special? Part of an array? Could be, yeah. So enums essentially mean that they are Evolve says, "Is this just another language?" Yeah, are you talking about SQL? Because yeah, we're writing in SQL today, and that's SQL is a database language. It's used by for data analysis or for working with databases in general, and it's a great tool to have for any developer, no matter what language you use normally, whether you use JavaScript or C or Python or whatever. Knowing SQL can be really helpful to you in working with data and working with backend. So yes, that's what we're doing today. Welcome to the stream, by the way. So an enum essentially means that it is part of a sort of a limited list, right? So if I define this activity type column as an enum, it can only be a specific subset of values. So in this case, it looks like activity type is an enum of type start or end. So anything that gets inserted into that column can only have two values. It can either be start or it can be end. It cannot be anything else. If I try to insert any other value into that column, it's going to error out, it's going to fail. So enum specifies, hey, only a limited subset of values are going to be allowable for insertion into this column. So unlike this one where it could be any integer, enum says, nope, it can only be start or end. Just like in, yeah, I suppose, yeah. If you're thinking about it that way, yep. Can only be a limited, limited amount of things in a specified list. Sure. And then the timestamp is going to be a float. And what float essentially means is that it's a decimal. So we can see that down here in the data. All right. Timestamp is a float representing the current time in seconds. Start means the machine starts the process at the given timestamp, and end means it ends at the given timestamp. And we can see that here, right? So machine ID 0 starts process 0 at 0.712, and then the same machine ends that process at 1.52. And then the machine starts process 1 at 3.14, and it ends process 1 at 4.12, and so on for each machine. So they're each performing process 0, and they have start and end times. Okay, The start timestamp will always be before the end timestamp for every single machine. So we're never going to get a negative value if we were to take the end timestamp minus the start timestamp. That would never be a negative. It will always be positive, which makes sense if we're talking about time here, right? You can't go back in time unless you're the doctor and you have the TARDIS. Uh, Everybody says, "Are you doing AOC in SQL?" What does AOC stand for in this context? I can only think of Alexandra Ocasio Cortez. Trazio says, "But who is giving the declaration of enum? What if there's a value pause between start and end?" It the enum so all data types um, are specified when you create the table. So whoever creates this table is going to specify what's allowed in each column. So if I'm just inserting records and I didn't create the table, I can't insert anything that isn't valid. So with SQL, data types for columns are always specified when the table itself is created. And you can do things, you can convert to a certain degree. If certain conditions are met, you can change a data type for a table, but it's pretty fiddly depending on what you're trying to do. Oh, advent of code. Okay. I didn't know what AOC meant. Oh, got it. Yeah, I've seen people doing that. I have thought about it. I didn't get on it right at the start of December though. I'm not really familiar with advent of code. I've heard of it and I've seen people do it, but it seems kind of interesting. Is it just where you do a problem a day? Something like that? Uh, so what is the question here? There is a factory website that has several machines, each running the same number of processes. Okay. Write a solution to find the average time each machine takes to complete a process. Okay. The time to complete a process is the end timestamp minus the start timestamp. That makes sense. The average time is calculated by the total time to complete every process on the machine divided by the number of processes that were run. So, if we were to think through that up a little bit, on machine 0, there are two distinct processes, right? Process 0, process 1. Each of those has a start timestamp and an end timestamp. So what they want is for us to first calculate the time between the start and end for both processes, right? And then take the average of those two values for machine 0. And then we do the same thing for machine 1 and for machine 2. So the resulting table should have the machine ID along with the average time as processing time, which should be rounded to 3 decimal places. I love rounding. Return the result table in any order. So let's take a look at what that output looks like. So for machine 0, processing time should be 0.894. For machine 1, 0.995, and for machine 2, 1.456. Hey, third. Great. Awesome. That's awesome. Thank you so much for sharing. I'm glad that's been helpful for you. Yeah, that's the goal, right? I always love to hear that. That's great. Thanks for popping in. Welcome. Feel free to stick around if you want. Okay, so and here they're showing the math. So it's really just saying, all right, so for machine 0, we take process 1 first, starts at 1, or which ends at 1.52, then we subtract, or sorry, this is process 0, my apologies. So we're taking essentially these two records here, both for process 0, 1.52 minus 0.712. And then we do the same thing for the second process, 4.12 minus 3.14. And we find the difference there. And then we take the average of those two, and that returns an average value of 0.894. Okay, so I hope the basic math makes sense. And if you're hung up on the basic math here, let me know and we'll talk through it, and I can actually do the calculations on a calculator for you here on the screen. Otherwise, we can keep going, but just stop me if you're hung up on the math, because if you're hung up on the math, the rest of it's not going to make sense. But I know that everybody has different strengths in math. I'm not particularly strong in math, and so I know how that feels to get left behind at the beginning of a question. and then not get the rest of it because I'm stuck on first principles. So I know that feeling. I refused to learn as a child. I refused to learn multiplication, uh, like just refused. So that was a bit of a hang up for a while. Evolve says, I wasn't paying attention. Can you explain? No worries. I appreciate your honesty. They say what the question is asking for is they want the machine ID. Where is it? Where's the write a solution to find the average time each machine takes to complete a process. So essentially what they want us to return is one record for each machine ID. And the value that they want there is the time it takes, the average time it takes to complete a process in general. So for each machine, we have two processes, 0 and 1, right? Process 0, process 1. And that's all happening on machine 0. And each of those processes has a start and end time. Okay? And so the time it takes to complete a process is the end time minus the start time. That gives us how long it took to get from start to end. So end minus start gives us the time it took to complete process 0. And then if we do the same thing for process 1, we get a different time. But they want the average. So we essentially need to take how long did it take to complete process 0? How long did it take to complete process 1? And then average those two. And so in order to find an average, you sum both values together, and then you divide by the number of processes. In this case, it's 2. So that's how you calculate an average. So how long did it take to complete process 0 plus how long it took to complete process 1 divided by 2 gives us the average for machine 0. And then we do the exact same thing for machines 1 and 2, which gives us an output table that looks like this. Okay, does that help, Evolve? That's what the question is asking for. And you can see the calculations here. Our SQL is going to obviously look a little bit different, but essentially this is the calculation we're going to be doing. Okay, great, awesome. All right, so select star from, what are we selecting from? What's that table called? So our table is called activity. And essentially what I want to do here is I want to be able to compare this record with this record, this record with this record, basically any record that has a match on machine ID and process ID. So where we have a match on both machine ID and process ID, so it's on the same machine and the same process, we want to compare the start record with the end record, right? We want to create pairs and do calculations against each of these pairs. Okay. Hey, Grizz, good to see you. Good to have you here. So what I'm going to do is yet again, we're going to compare, since we're comparing two different records in the same table, we're going to have to do something to join this table to itself, kind of like we did for the previous question. So what I'm going to do here is I'm just going to say activity T1, and this time I'm going to inner join activity T2. Now, not that it matters so much, but here we're going to go ahead and just use an inner join. So we only return matches with valid criteria from activity in both cases. Now, we already said we want to create pairs between machine ID and process ID. So those are going to be the first two criteria that I want to join on. So I'm going to say, essentially, only compare records for the same machine. And only compare records for the same process. Oops, sorry. One, my apologies. Two, we go. All right, because for example, I don't want to accidentally compare, say, I don't know, the start of process 0 against the end of process 1, right? That's not going to give me something that I want. I only want to compare the start of process 0 with the end of process 0. So this is going to ensure that we're always looking at the same machine and that we're always looking at the same process. And this also shows you how to do multiple criteria on a single join, right? So my first criteria always has to start with on. So I say on, and then I give the field I want to join on. And if I want to add additional criteria, I use the and keyword. So I can say on my first criteria, and then and my second criteria, and then I can use and as many other times as I need to for as many additional criteria as I need. So it's sort of like a where clause a little bit, right? You can just use that and keyword to keep adding additional comparisons. Now, I want to compare the start value against the end value, right? I want to compare start against end. So, how could I do that? I'm already going to return essentially two records from this comparison, two records from the same table. Oh, you want me to execute this portion only? We can do that, sure. It's going to be a little bit interesting, but do it. We are going to need, I'll tell you this, we are going to need additional criteria. As you can see, it looks a little messy. Let me see if I can make this a little bigger so it looks clearer. There we go. That's better. All right, so we can see we're comparing our table against itself, right? So here's our table 1, here's our table 2. And right now I'm returning essentially the start value from record 0. And now this is where it gets interesting. So I'm matching on machine ID and process ID, right? So first row, machine ID 0, process ID 0. Matching machine ID 0 and process ID 0, right? And then the second record in my base table, I'm still matching on machine ID 0 and process ID 0, but here's the start value again, because we didn't provide any additional criteria. So it's just going to pick an arbitrary match. It's just going to pick an arbitrary match. So in this case, it said, oh, hey, this record matches machine ID 0 and process ID 0. And well, hey, so does the same for this next row. The same record matches again. I'm just going to use that. And for this next one here, same record again. And same record again. So what it's doing here is it's saying, well, there's a bunch of different ways that I could match against machine ID 0 and process ID 0 between these two tables. So it's returning all possible permutations of that match. Right? Because we don't have enough criteria here. So it's saying, well, there's 4 possible combinations that I could return here of, putting these rows together. And so that's what it's going to give us. So obviously we need to do a little bit more filtering here, right? This isn't what we want. I don't want to match start against start. I don't want to match end against end. I essentially want to match end to start or start to end. I want these two, right? Essentially, I only want one of those two. So I really need to just get it down to one record for each of these. So how can I do that? I need another criteria here. Renita's thinking, yeah. What if I did something like this? What if I said, I only want to look at records? Object oriented. Thank you so much for the follow. Much appreciated. Good to have you here. What if I only looked at records that met these criteria that we already have and where our activity type is start for the first table, right? So that essentially gets us down to 2 records for each. So we're going to run it at each step here to visualize. This should reduce our record count. Yep. So it's going to reduce our record count a little bit more. We haven't lost any data, but I still have 2 records here, right? I want to get it down to 1. I want to get rid of this one right here. So how do I only return this second record? What's the last criteria I need to add to just get the record that I have highlighted? What's the last unique thing I can filter on? Or the last what's the last thing that I want that makes this record different from this record, first record? And what? This activity type should equal start. And what else? Hmm, not the timestamp, because the timestamp is going to be different. Timestamp is going to be different for every record. So we want something that is going to be, for example, maybe something that could only be one of 2 values. A field that we know is limited to certain values. We already did that here, right? We said T1 activity type equals start. But what else could I filter on? Where something that could only be one of 2 values? Maybe this one over here? Because these are 2 separate columns. They have the same name, but they're separate. Yeah, and T2, right? We need to say T2 activity type equals, now let's think carefully about this. So right here, I'm filtering on this column. Now, I want to add a filter to this column, and I can do that by saying T2.activityType. However, to do my calculation, calculate the time it takes to complete a process, I need to subtract the end time from the start time. So T2 activity type equals what? Should it be start or should it be end? If I want to do my calculation. I'll cover that in just a second, Bamboozled. That's a great question. Or Bamboozled, I'm sorry. I will cover that in just a second after we answer this question. So let's look at the output here to help us decide what this should be. Do I want to return this record? Or do I want to return this record in order to do my calculation? In order to get the time difference between the start and the end, what should this be? Should this be start or should it be end? Yeah, you want yes, exactly. As D-Rocks and Petrazio said, this should be end because I want to do the subtraction, right? So let's run this again. Now we're cooking, right? Because I have the end time for machine ID 0 and process ID 0. I now have both the start time and the end time on the same row. That means that I can do calculations on them. But in my select statement, I can do calculations now. I can say, take this timestamp minus this time. Okay. Same for process one, right? I now have both the start time and the end time. Same for machine one, process zero, et cetera, et cetera. Now I have unique machine IDs and unique processes, and I can subtract the start time from the end time for each one of them. Awesome. So now I have the data that I want, and now I just have to do the calculation in my select. Okay. I'm going to pause here for a second. Does it make sense what we've done here? And you can say, I'm confused. You're allowed to say that. Or you can say maybe that you don't know why we did this. Or you can say, nope, I'm good. Go ahead and let's do the calculation. I just want to make sure to pause here for a sec. And I want to answer Van Boozle's question as well. Bamboozled. It's like, I have trouble saying that. I don't know why. You got it. Awesome. Okay. Well, feel free to speak up. Anybody else, feel free to speak up if you're behind the curve here. That's perfectly fine. You're allowed to be. Like I said, I was pretty terrible at math. I still am. I'm not good at math. So when we deal with math heavy questions, I like to go fairly slow on them. Renate says, why do we add more ands to the inner join and not use where clauses? About this. So essentially, what the join is doing is something very specific. It's lining up the rows and putting them together. The where clause would filter those rows. It has nothing to do with the matching. The important part here is the matching. Which rows do we put together into one single row so we can do calculations on it? There's a difference between join criteria. There's a difference between join criteria and where clause filters. Where clause filters limit your results to only things that meet those criteria. Join clause matching criteria, like on and here, those are very specific to tell the engine which rows combine to create a single row. So it's telling them how, okay, what do I splice together here? Right? So Bamboozled, before we move on, I want to answer your question. Why did we use is to find null values, but now we're using equals? Yeah, so null is kind of weird. And we talked about, I wasn't sure if you were here when we talked about null before, but I'll go over it really quickly again. Null is something special in data. Null means there's nothing there. It's empty. There's nothing to add. There's nothing to subtract. There's nothing to multiply. There's nothing to divide. There is no number. There is nothing. That space is empty. That space is vacant. So if a space is vacant and I try to say something equals a vacant nothingness, it's not possible. I can't do that. I can't compare against something that doesn't exist. So that is null keyword. It refers specifically to null values, saying like, hey, null is special. Is there a null here? Whereas equals is essentially referring to there is something in this space. It could be a zero, it could be an empty string, but there's something there. The toilet paper roll is, maybe there's just the toilet paper roll might be empty and it could just be the cardboard tube sitting on the rack, but there is something there, right? Empty toilet paper roll, exactly. Yeah, we talked about that earlier. Yes. So it's null is a very specific entity when you're talking about databases. It's different than a zero or an empty string. It's literally the absence, the nothingness. Kind of reminds me. I just watched the new Doctor Who episode yesterday, and they go out to the edge of the universe, and they're in the cockpit of a ship, and beyond the outside the window, there is literally nothing. That is the null space, the no space. Um, and there's nothing there. So nothing to compare to. That was a good question. Rex says, a bit of a tangent. Do you subset your database at work in order to experiment with finding the most effective and efficient SQL queries? Um, Subset your database at work. So are you meaning experiment with smaller data sets? I mean, yes. So our the tool that we use, which is called PL SQL Developer, it's a piece of software where we write most of our SQL queries. It actually kind of does that, helps us do that, because when I run a query, it's only going to return X number of records by default. So even if there's like 5 million records in a table, it's only going to return. If I do a select star on a table, it's only going to return the first, like, I forget how many, like as many as fit in the window. It's only going to return that number of records. And so that lets me say, oh wait, maybe this table has way more columns than I thought, or some of these columns have a like really long strings in them, and so I know that's going to slow down my query. So yeah, I mean you can use the software to kind of make sure that you're not going to blow up the database by running a select against a really massive table. Hey Dana Webb, welcome to the stream. Good to have you here. Yeah. So a lot of SQL specific tools will have stuff to help the developer, not screw up. And that's one of them. Is you can kind of get a sample, a little taste of what's in the table by just running a select star, but then you only get the first 30 records back or something. Okay, so we have our set of data that we want to consider. So now let's actually do the calculation part of it. All right. Yeah, and you can in in certain languages, you can also do things like select. I think in SQL Server, you can do like select top 10. Like if you want to limit to only 10 records or like 100 records, you can do select top 10, top 50, top 100. And that'll just only return the first 10, first 50, first 100. So there's other things you can do as well. Hey, Viraza. Thank you so much for the follow. Yeah, limit. Yeah, a limit is another keyword you can use to limit to a certain number of records returned. Exactly. So there's ways you can do that. Yeah, and that's a great summary there as well between join and filter. You want to join the tables, like I was saying. You want to be as explicit as possible with the matching that you're doing of rows. And then once you have that, you could add a where clause if you need to in order to then limit the number of records returned. So you want to make your joins as clean as possible, as Rox said. And then you can filter once you've had your nice clean join and you have all the data on the correct rows. Then you can add a where clause if you need to limit the end row count. Yes, and there's other tools in there that can also help stop developers from screwing up, which is things like limiting deletes or limiting your access. There's so I mostly have full access at work to a lot of databases. I can do anything I could. I'm not gonna say I would, but I could do pretty much anything I wanted to in several different databases. However, there are certain databases where I can't. I can only do selects. I can't do inserts. I can't do updates. I can't do deletes. I can only do select statements against those databases. And that's the way it should be. Your access should be limited to only the data that you um, and if you don't need to write anything to a database, then you shouldn't have access to do that. Your database administrators should be keeping a tight grip on what you're allowed to access and what you're not allowed to access. Okay, let's do the calculations. So first thing I know I need is that they told us in my output, I need at the very least, I need the machine ID. So I'm going to go ahead and just grab that from T1, machine ID. And it wouldn't really, in this case, it wouldn't really matter what table we grabbed it from, but T1 is just more logical. So I'll get that from there. Now I need to actually do the calculation. So to calculate an average, we take the higher value minus the lower value and then divided by, well, so in this case, we're going to take We're going to find the time it takes to complete both processes, so process 0 and process 1. And then we're going to divide that by the number of processes, which is always 2. All right. So at the very least, I'm going to need to subtract the end time from the start time. So we'll start with that. Then we'll build more around it. So T2 dot timestamp, grab this T2 dot timestamp minus T1 dot timestamp for starters. And so what that's going to do is it's going to say, all right, T2 timestamp 1.52 minus T1 timestamp 0.712. Cool. All right. Now there's actually an average keyword that we can use here. So we could do the calculation by hand. We could say, you know, um, we could say, uh, you know, this plus this, divided by 2, etc., whatever. But I'm not going to. I'm going to use the keyword that's built into SQL that just does the average calculation for every record it encounters. So essentially what it's going to do here is it's going to say, all right, for this one, for each machine ID, right? So for machine ID 0, find the average of the records for that machine ID. Okay, so for this machine ID, find the average of the time it takes to do each of those processes. And we're going to call that processing time. Now, if I want to essentially, see how to describe this, if I want to essentially bucket these averages, I want to essentially bucket these averages in terms of machine ID. What can I add to my query to create a bucket? So I put each of my averages in the bucket of machine ID. What could I add? Yeah, if I want to create a bucket, the way we know how to do that is with a group by. So I'm going to group by machine ID. Right? Because I only want to average the timestamp values for each machine ID. So these two together in the same bucket as an average, these two together in the next bucket as an average, and these two together in the next bucket as an average. So what are my buckets? My buckets are machine IDs. All right, so let's run this. Let's see what we get. There's something else we'll need to consider here, but let's run it first and let's see what this looks like. Okay, it did get accepted, but I can tell you that we're missing something. This would fail if we tried to just submit it right now. It would fail a test case. So we need to read the question carefully and see what we're missing. So this part in bold here, it said a resulting table should have machine ID along with the average time as processing time, which should be rounded to 3 decimal places. So the last thing we need to do here is we need to take each of our averages and we need to round them to put into our result set. That's very easy to do. There's a keyword for that, as there is for a lot of things. We want to round. And the second part to this round function is we need to tell it how many decimal places we want to round to. So in this case, I want to round to 3. So what we're doing here is first we're calculating the average value, and then we're just rounding it to 3 decimal places. And then in our result set, it needs to be named processing. So we're aliasing this here as processing time, and we're essentially creating a new column, right? So this didn't exist in the source table. Processing time doesn't exist. But using an alias, we can do a calculation, give it a name, and create a whole new column in our results. And this, yay. Oh my goodness, Petrasia, you were provided DB administrator roles as a supporter, but I was lucky I didn't do any damage. My goodness. Yeah. Yeah, that's your DBA's fault right there. That was accident. My goodness. Wow. Zero trust, lowest privileges. Exactly. Yeah, you work at a cybersec company, so it's baked in. It should be baked into every company. Lowest, zero trust, lowest privileges. Yep, exactly. That can be frustrating sometimes, but really in the end, if it stops you from doing something stupid, especially when it comes to a database, like I'm like, man, just limit my privileges, don't give me passwords for stuff I don't need to know, like just lock me out. Oh gosh. All right. Run this one more time. Yeah, you should not have had that access. Okay, so we know it worked already, but let's run the test case here. Yay, it works. Hooray. So this is another example of how we can essentially take two tables and link essentially link a table to itself to directly compare two records against each other. Because what we're doing with this join, in essence, is we are fudging it so that two records get smushed together into one single long record that contains all the fields from both records. So we're taking two records that used to sit, one above the other on the table, and we're saying, actually, we want you to sit side by side so I can treat you as a single row and do all my calculations. So you're just joining it to itself on the particular criteria that you need, and then you're putting it in the proper bucket and calculating your averages based on that chosen bucket, right? Now, as I said at the beginning, this stuff is a little bit more advanced, so you're not going to understand it right away. That's okay. It's giving you a taste of some of the analytics types things you might end up doing with data if you get into this field. And this is not the kind of thing you're going to have to know right off the bat. Learning SQL generally comes with a lot of experimentation. Kind of like D-Rox was saying earlier, is that you experiment, you try stuff, it doesn't work, you go back, you refine it, you tweak it until it finally gives you what you're looking for. So writing SQL queries is very much an iterative process. But the more keywords you know, the more principles you know, the faster and better you'll be able to write those queries. Okay. Any questions on this before we go on to the next one? Actually, we're going to take a break too. We missed the last break because I was on a roll, but there's another small concept I want to cover. Let me find. Yeah. Okay. Yeah. The next one, there's a very specific one. They're useful. Any questions before we take our break? Okay. Cool beans. And again, I'll say this too before we break. Probably my favorite thing about SQL is how flexible it is for experimentation. Um, so SQL is meant to be an exploratory language that helps you get get data out of a database and understand the data that you have. So it's very exploratory. It's very much like a multiple draft type process. So you're not going to turn out your 90% of the time, you're not going to get your query right on the first try. So I want to emphasize that. You're going to get it wrong. You're going to get errors. You're going to get data you didn't expect. And you just keep running it over and tweaking it and running it over and over and over again until it works. So you're probably most of the time you're not going to build the perfect query. But what's important is that you can, if you're in an interview and you're trying to build a query, that you can talk through it and understand at least why you're adding the things that you're adding, even if it doesn't work. As long as you can say, yeah, this is what this is supposed to do, then it's probably going to be okay. Petrozio says, okay, having such a table that requires a self join, does that assume the DB design wasn't perfect in the first place or not at all? So a lot of the times what you'll find is that the data in relational databases isn't or the tables in relational databases aren't necessarily created or designed for humans. What they're designed for are machine transactions. Oh, thank you for the follow, Regalius3. Thank you for that. Good to have you here. So this is a good example of this actually. If I was a machine, if I was one of these if I was one of these, uh, I don't know what industry this is. If I was one of these industrial machines that is, I'm logging my own data, right? I'm starting tasks and I'm logging them as I go. I'm logging my status to the database automatically. And that's what happens a lot of the time. Thank you for the follow, Clue 355. Good to have you here. Um, so a lot of the times machines will send automated stuff to the database. That machine isn't going to be smart enough or care enough to write a record for its start time and then send an update request, like locate the existing record and update it with its end time. A lot of the times, what you're going to get is exactly what's in this table, which is the machine is when it starts a process, it's going to ping the database and insert a record saying, "Hey, I started," and then it's at some indeterminate time in the future, it's going to send another record with its identification and the current process it's on. It says, "Hey, I'm done. This is when I ended." So from automated transactions, a lot of the time, this is the kind of thing you're going to get is one record for a start, one record for an end, or I don't know, one record for uh, the start of a sale, one record for the end of a sale, or one record for payment or whatever. So it's not that the design of the database is bad. Sometimes you just got to deal with what the input that you got, right? And in this case, the input that we're getting from this machine is just a new record anytime a status changes. That's pretty common actually. Yeah, you could derive from a source which cannot design. Yeah, the source isn't always going to be clean. The source isn't always going to know how to make the data digestible by humans. Sometimes all you get from the source is what you get, and then you have to be able to clear it. You have to be able to query it properly. And as Regalia 3 says, yeah, there's other types of databases other than relational databases and document-based databases. You can tailor your type of database to meet the needs of your inputs. But I will say this. So in my day job, I work with a data warehouse, which is basically like a big data repository for tons of databases. It's just a big old bin where data just comes in. It's just pouring in from all sorts of sources everywhere. And so we use relational databases across the board because our data is coming from so many disparate sources. Sometimes it's entered by humans, sometimes it's entered by automated transactions, sometimes it's entered by machines, sometimes it's entered by other databases, and it all comes in to the same data warehouse, and we have to be able to do analytics against all of it. So the one size fits all solution for us is a relational structure for all the data in order for us to potentially mix and match as much of the data as we want, to do joins any two things at any time. The one size fits all solution for us is relational. And so that sometimes means that, I should say, one size fits most, because sometimes, yeah, that means you're going to end up with data structures in your table that are less than ideal. The data just ain't pretty. And we've talked about that several times before. It's very common. The most common type of database structure is relational that you're going to encounter in a corporate environment. It's relational. And so sometimes the shoe doesn't quite properly fit. And so your data is going to look like this, where each independent row isn't going to give you anything valuable until you manipulate it a little bit more to extract what you really need. And so there's a lot of reasons why you can have slightly fragmented data like this. And it could be because the source is limited in that way. It could be because the table was originally designed for something else. And now you're trying to use it for something it wasn't designed for. There's all sorts of reasons. And so if you're working with, if I was just working with this data in a vacuum, right? If I was only concerned about this type of data coming in, then yes, I could tailor my database type to be something different, like a ledger database, or there's all sorts of alternate database structures. But In a data warehouse situation or a data lake situation, you're usually going to find relational databases being used for everything, but not always. I'm not going to paint a blanket brush here, but that is by far the most common. So I hope that helps a little bit. It helps to think about why stuff like this happens. Like why do we even know about, why do we even need to know stuff like this? Why is this an interview question? Because it's the kind of thing you're going to run into more than you would like to. Because data oftentimes data sucks, and you got to know how to make it suck less by writing good SQL. That's why SQL is so valuable, because the SQL that the data that powers literally everything, the data that powers medical decisions, the data that powers AI, the data that powers you know police forces, the vital stuff that keeps our world running is oftentimes much worse than you might think. And so you got to be able to understand what's wrong, know how to get valuable insights out of bad data, and that's so vital and so important, especially in the modern world now, where we are getting more and more reliant on quote unquote big data to make all sorts of automated decisions that we don't understand. Right? We're expecting computers to make really important decisions for us based on huge data sets. So if that data is wrong or bad, we've already seen it with things like with policing. Police forces are relying on AI that are trained on bad data sets or incomplete data sets, and that's having real world ramifications for people, for people's lives, for medical decisions. And so that's why you have to acknowledge my data is going to suck a lot of the time. I need to be aware of it. I need to know how to work with it, and I need to know how to make good decisions from bad data. So that's I get a little fired up about that, but it's really important to me because people just don't know. People think data is infallible. People think computers are infallible, but every computer is trained on data. And where does data come from? Everywhere. Who the heck knows? Who knows if your source is good? You have to know how to work with it and to extract insights from it, or to choose to discard that source as bad, as something that's not going to give you any valuable data. So don't use it. That's why I love teaching people SQL, to give you that power, to say you can be the the arbiter of, you can help your team decide what data is good, what data is bad, and prevent them from drawing the wrong conclusions from it. So it's very important to me. People don't know how much data there is under the surface of your everyday life. Okay, I got to catch up with chat. I was monologuing. I apologize. Regalia says, "Are you a DE? I assume you mean database engineer." Yes. So I'm a senior business intelligence developer. So developer for a major university here in the United States. And so, obviously, being a major university, the university itself is about the size of a small city. So there's quite a lot of data coming in at all times. And so our team is in charge of that data warehouse and maintaining that data, making sure it's good, making sure that the people who are making the business decisions can get valuable insights and correct insights from that data. Oh, that's funny. Dana Webb, I'm sorry I blocked your message earlier. It saw the abbreviation of STI, and it my auto mod assumed that it stood for something else. Oh, I love it. That's funny. But it's added that as a permitted term now, so I probably need to block that term again later. Dano says, "Have you worked with databases that are written by applications using single table inheritance? Does that create extra complexities in working with raw data?" Um, Single table inheritance. I don't think so. I'll need to think about that question a little bit more. I'll think about it over the break. Yeah, and then I'll answer again if I was wrong the first. Drox has written a very detailed explanation here for what's going on in this table, and they're correct. Yes. So as I kind of as I mentioned earlier, this table is not badly designed for what it's doing. Right? It's taking in individual transactional records, and that's what you see often. Um, Ooh, and Drox is getting technical with the definitions. I like it. Third normal form. Yeah, and it's like we were talking about the problem. So the way the data coming in, there's nothing wrong with it. But what the problem is when you want to do reporting, right? Yeah, exactly. Yep, yep. Yeah, the problem is and that's an important thing to remember is that data stored in tables is not necessarily meant to compatible with the way humans read data. Yeah. Wolfie says, does a database engineer have to know about all the types of databases out there? MySQL, Oracle, Postgres? No. So I started out in my career using Microsoft SQL, so T-SQL, which we're doing here. And then at my next job, I had to learn Oracle SQL. And then a lot of the projects that I will do using SQL, like the full stack projects that I build here on my stream using SQL, a lot of those are using Postgres because it's open source, and so that way anybody can build a Postgres backend. It's very easy to do using free tools online. So I myself know three flavors, but you don't necessarily have to. I have some coworkers that have never used anything other than Oracle SQL. They've never used Microsoft SQL. They've never used Postgres. None of that. So it just depends on where you work. Most corporations are going to have their flavor of choice of SQL. So like the first company I worked for, they used they used Microsoft SQL Server for everything. Um, and the where I work now uses Oracle for everything. So it just depends. But what's it can be helpful if you if you do know some of the differences in between. If you're looking for a job using SQL, you should probably know some of the main like keyword differences and things like that between the big flavors. But you don't have to be well versed in everything. Usually, if you know one flavor pretty well, if you can do the basics in one single flavor, you can just say, hey, if you go into the interview and they're like, hey, we work in SQL Server here, you can be like, well, um, up to this point, I've only ever worked with Postgres. So I'm gonna, I can solve these interview questions using Postgres, and then you can give some examples of how you're a quick learner and you can pick up concepts really quickly, and it's not that much of a challenge to learn. No worries. Mhm. All right, so break time. We're gonna take 5 minutes and we'll come back. We'll do one more small question before we wrap up today. Um, and because it's a very important keyword, and I want you to know it. So I promise it's much smaller than this one. Like a 4-line query, I think, but it introduces a very important keyword, and I really show it to you. So I'm down off my soapbox for now. No guarantees. I won't perch up there again at some point, but I do want to do one more problem with you guys before we wrap up, to introduce another good keyword to know. Because this keyword that I'm going to introduce to you after the break is the kind of keyword that makes you feel a little bit fancy when you use it. You're like, ooh, I can be fancy here and use this keyword to do a little bit extra. So I really like it. I think. All right, 5 minutes, and I will see you all back here shortly. All right, folks, we've got about a minute left in the break, so come on back if you're coming back. Go ahead and get a drink of water if you need it. Get up and stretch if you've been sitting this whole time. What are you doing? Get up and stretch if you're able to do that. Pet your dog, pet your cat, pet your significant other with their permission, of course. Use the restroom and then come on back. Rex, I'm glad you like the new BRB screen. I like it too. I paid money for that. Can you believe it? Ah, this music is composed by the very talented Chris P. Nugget. You can see their handle there below the timer. The song is called White Noise. The album is called Resilience. And the Twitter handle is Chris P. Nugget R. Yeah, great composer. All right, we're back. I just realized I seem to have lost my transitions. I have the cool zoom out effect that was, I used to have like a cool thing where it would zoom in and zoom out when I switched screens, and I don't know where that went. Disappeared. So I'll have to get that back. Hope it was not too expensive. No, it wasn't. So I was thinking about the single table inheritance question, and I wanted to pause for a second and just I wanted to find a good. I like visual illustration, so I wanted to show what when we say single table inheritance, what are we talking about there? And so I was googling for a good visual representation of it. And so when we say single table inheritance with that question, this is what we're talking about. So when you are translating from some kind of an object oriented language, so something that has inheritance and classes and that kind of thing, relational databases don't support that. So, for example, in like a document based database, right, I could have a field in a document that contains a nested object or a nested array. And then that could contain a nested array. And you could be nested all the way down, right? But on their face, relational databases don't support that kind of. And so when you're doing single table inheritance, you essentially when you're trying to pull data in from some kind of a mm, some kind of an object that supports inheritance, you have to essentially flatten the data down, and so into um, a basically a single layer table like this. So that's what that. I thought this was a decent good because if I was going to try to just verbalize it without any kind of a visual, I don't think it would go over well. So essentially, that's what's happening when we talk about single table inheritance. And I was trying to think of some specific examples of that type of data that if I have to deal with that, at work. Like I was trying to think of something specific and I can't think of anything at the moment, but I'm not ruling it out that I've dealt with it. I can't think of any specific examples of, um, yeah, I'm not saying it doesn't exist, but I can't think of anything at the moment. Oh, hey, Robodom, good to see you. All right, last question I want to do to introduce a very important and fun keyword is let's see, class is more than 5 students. This one right here. All righty. So I'm gonna get rid of this. And even if you saw that solution, that's actually not the solution we're going to use. So that was another one I was trying, just for funsies. So you didn't even get a preview of what the answer is going to be. That good. All right. So here we have a table called courses, and it only has 2 columns: student and class, and both of them are varchar. So what is type varchar? What does that mean? Something's declared as a varchar. What is that? Yeah, it's essentially a string, right? It's text of some kind. I'm gonna we'll say it's a string. So it contains alphanumeric characters, right? Now, in sometimes in tables you'll find that things that are technically numbers can also be defined as varchars. You'll see that sometimes things will be a field that only contains numbers might end up being defined as a varchar. You can do that. But you can't, for example, put a varchar inside of a field defined as like an integer, right? Because you can't put a string inside of a number. So yeah, varchar essentially means string. And sometimes you'll see things declared as like a varchar 32, in a table definition. These don't have it, but you'll see something like this in a table definition. And any guesses on what the 32 stands for? So you might say something like, I'll just copy this. So you would see something like, any guesses on what that 32 might stand for? Yeah, it's the length that we are allowing that string to be. So if I insert something in here, it could be anywhere from 0 to 32 characters long. Yep. And you'll see that a lot with table definitions. They'll often specify a specific length for that field to be. And if you try to write something in there that is longer than that, you might end up with truncated data. So you might end up with some data loss, or it might error out and not even allow you to write that row at all. So it just depends. Yeah. Okay, so that was more of an aside. That's not really relevant to the question. I just wanted to cover that real quick. So student and class work together to be the primary key for this table. So even though there's only two columns in this table, student and class, they themselves are also the primary key. Each row of the table indicates the name of a student and the class in which they are enrolled. Okay? We want to write a solution to find all the classes that have at least 5 students. Return the results table in any order. Okay, so for this particular example, we're given a list of students. So, and the students are signified by these letters A, B, C, D. These could be anything. These could be, 1, 2, 3, 4, 5. It doesn't matter. These are just the individual students. And then the classes are listed here. So they want, what was it? At least 5 students. Okay, so math has 1, 2, 3, 4, 5, 6 students. So that would qualify. English has 1 student, biology has 1 student, and computer has 1 student. I wish I had a class just called computer. That would be great. Who knows? What are they going to talk about? Who knows? It's computer. But in the end, the only one that meets the criteria is math. So essentially what we have to do here is we have to figure out how to count, right? We need to figure out how to count each of these values. And then in the end, and then after we've counted them, we need to only return the class where that count is greater than or equal to 5. Robodom says, I'm the best student in computer. Yeah. I computer real good. Yep. Okay. So let's think about how can we do this? Well, one way we could do this is by building something called a CTE, which I can never remember what that stands for, but I know what they're for. I just can't remember what it stands for. Oh, is it something table expression, cross table expression? What is it? Well, essentially what it allows you to do is it allows you to build a temporary table first, doing some kind of a calculation, and then you do a second select off that temporary table to then refine your results. So we could do it that way, and that's the way I actually originally did this one. And then I was like, oh wait, there's a much easier way we can do it. So first off, let's do this. Common table expression. That's it. Yeah, I don't know why I can't. That doesn't stick in my brain. I don't know why. So select class from courses. We're gonna do this first. See what we get. Yeah, why common? That doesn't specify what that does at all, right? Yeah. Okay, so if I just select class from courses, I essentially just get a list of all the classes. And that's essentially the only field that we want to return here, right? In the end, we only want to select class from courses. So great. Now we need to do some kind of a calculation on this to only return the class or classes that meet the criteria that was specified. Okay. So if I want to do, if I want to get like the number of students who are in math, let's say, if I want to get the number of students who are in math, if I want to, I don't want to say the word, but if I want to get the number of students who are in math, what might I do? Might I do? I want to get the number. Yeah, we could do a count. So we'll start with that. Let's do that first. All right. So I'm going to say select class, and then I'm just going to count. So I want to count um, student, right? I'm going to count student, and what should I be grouping by? What is my bucket? What How do I want to divide these counts to give me meaningful data? What's my bucket? My group by? Yeah, group by class. All right, so let's see what we get now. I'm going to count student as um, class count. And you don't have to alias this, but it looks better if you do. So I did that. All right. So great. Okay. So that's telling us that we have the appropriate grouping, right? Biology, computer, English, and then math. So now we need to refine this even more so that I'm only returning the value of math. So what's a way that I can, and if you know the answer, don't say it, but just in general, um, well, I guess if you know the trick, don't say it. But what's a way that I can filter a query, just in basic terms? How do we normally filter queries? What do we always do? Filter a query. Yeah, where, right? So, all right. So first thing I need to do is I need to get my count, right? And I need to get my buckets because what I'm trying to filter is the bucket count, like how many students are in this math bucket. So I need to do my group by first, right? The group by has to happen first so I have the correct count. And then I'm going to need to filter on that. Okay. So I'm going to say where and I'm going to do this where count student yeah, greater than or equal to 5 essentially, right? Yeah, and good catch on the yeah, and then great catch on the greater than or equal to. Yeah, exactly. So this should be greater than or equal to because they specify that in the question, at least in general, greater than or equal to. So I'm going to try it because this makes logical sense the way we've written this. So let's run it and let's see what happens. Because this is what we have to do, right? We have to get our count, we have to group it, and then we have to add a filter for this. So let's run it. What do we get? Uh-oh, get an error. What's going on here? What? What? The flip. All right, so let's read the error. Incorrect syntax near the keyword where. Whoa. This is written correctly. This is fine. I've written this properly. The problem here is the order of operations. So we touched on this just a little bit earlier. SQL keywords have to be written in a specific order. So for example, if I'm doing a join, I have to say the join type first and then the criteria that I'm joining on. So I have to say like inner join table 1, table 2, and then I list my criteria, right? And if I'm writing a select statement, just a regular select, I would have to always have my where clause after my from, right? It can't go before it. So just like with a sentence in English, the words have to go in a certain order in order for them to be grammatically correct. It's the same for SQL. Keywords belong in a certain order, otherwise, you're going to get an error. And the unfortunate thing here is that a where clause cannot go after a group by. A where clause must come before a group by. So we might think, okay, well, maybe all I need to do is just change the order. Maybe this needs to go here. Try that. What do we get? Still not working. What's our error now? An aggregate may not appear in the where clause unless it is in a subquery contained in a having clause or a select list. The column being aggregated is an outer reference. Okay, so there's a lot going on there, but it has given us the solution of what we need to do. So essentially, in essence, what I'm trying to say here is that we cannot use a where clause. Not going to work. But if I just run it without the where clause, I don't get the data that I actually want. There must be a better way, and there is. So there's one more keyword we can use here, which does essentially the same thing, but allows us to put something after a group by. And that keyword, blah, 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 which was sort of hinted by the error message, is having. So the having keyword essentially allows us to do this. Having count student greater than or equal to 5. So now if I run this, it's still going to be wrong because I have an extra column in there, but I want to show you clearly what's happening. Come on. Yeah. So now we can see it's giving me what I want, giving me the class where or having the count of student greater than or equal to 5. So it's doing the count and the group by first, and then the second calculation. Regalia says, "Who's that in your Twitch DP?" Oh, in my profile picture on Twitch, that is Pidge from Voltron, the Netflix series, which is very good, by the way. I recommend it. Yeah, that's the character Pidge who pilots the Green Lion on Voltron. Yeah, she's great. I love her to death. And I actually used to look a lot like her. I had glasses and short, spiky hair. Yeah, my hair used to be like an inch long, if you can believe it, and spiked up, with gel. And I had that, shaved that fade cut with the shaved on the side and the spikes up top. Yeah, big glasses. So yeah, I used to look like her a lot. Very good show. Yeah, absolutely. And I mean, robot lions, like you can't get any better than that. And I used to pilot a green mech lion. Yes, absolutely. Yep, in a past life. So the having keyword specifically allows you to add additional filters after a group by. That's what it allows you to do. And so this is a very useful and powerful feature to know if you are doing data analytics, because there's a lot of times I have to use this keyword a lot where you need to group your data first. You need to aggregate your data down first, and then after you know what it looks like, after you have your subtotals, and if you're summing things together or whatever, then you want to do even more additional filtering. So if you want to do that, you need to know the having keyword. And I actually did not know this keyword for years. Nobody ever taught it to me. And so I just assumed that you couldn't ever do additional filtering after a where clause, or sorry, after a group by. My apologies. I just assumed you couldn't do more filters after a group by. And so I would, take big old chunks of data and put them in Excel and do more filters there. And that's not always going to work. And so learning the having keyword was an absolute revelation for me. Bamboozled asks, why can't we use our class count reference? Yeah, let's try it. Show you. Oh, thank you for the follow. Return my shoes. That's a great name, by the way. I'm sure there's a story there, and I'm rather curious about it. But you don't have to share if you don't want to. But I love that name. Yeah. So if we do that, if we try to use this alias that we created, we're going to get an error. And it's going to tell us invalid column name. So most flavors of SQL, I'm not going to say all, but most flavors of SQL do not allow you to use aliases in like a having clause or even in a group by clause. It's just the way the calculation is run. It just doesn't associate this alias with the actual column. It's still going to apply the label in the results set. I read why this is, and I honestly don't remember the answer. But yeah, you're going to get this error, and everybody does this at some point. You say you create your alias, and then you're like, oh yeah, I'm just going to do this down here, and then you get an error, and you're like, ah, crap, and then you gotta actually put in that actual calculation in order for it to work. Now I'm thinking that MySQL, I think MySQL actually does support um, aliases in having clauses, but I may be misremembering. So now once I put that back, then it works. That's a great question though. And I just do it automatically, but I didn't think to explain why I was doing it. I appreciate that. Rex Rucker says, is there a way to tell when to use having versus where? Sorry if you've already talked about it. No, that's fine. So it's all about the order in which you're doing. So if you think about it this way, if you're doing any kind of a grouping, whether it's a count or whatever you're doing, if you're grouping but for any reason, a where clause must always come before a group by statement. Has to. The way SQL works. If you want to do additional filtering after your grouping, then use having. However, if you're just writing a basic SQL query and you're not doing any grouping, then you're going to use where, because you'll have a from statement and then where clause comes after a from statement and it works. It's fine. Good deal. So if you're not doing grouping, you will use a where clause. If you are doing grouping and you need your filter to come after the grouping, so if you're trying to filter on something like something that you're summing or grouping or averaging or whatever, if you're performing this calculation, grouping stuff into a bucket and then need to do additional filtering on those aggregated data, then you need to use a having clause. So the having clause is very specific kind of in its case, whereas the where clause is sort of your Swiss Army knife, multi-purpose filter. So most of the time you'll use where if you're grouping and you need to filter on something after the grouping takes place, the aggregation takes place, then you'll use having. Does that help? Okay, great. But yes, having is something that you can pull out in an interview and be like, I'm fancy. Um, and it helps you solve questions like this much more easily than you could without it. So just for funsies, I'm going to show you how you could potentially solve this without using having, although it's much easier to do it with having. So if I didn't remember that having exists, um, oh, and thank you for the follows, folks. I missed a few people here, so I'm going to thank you. I'm going to thank you, followers, real quick here. Hexatons, thank you for the follow. Kubadev, thank you for the follow. Return my shoes, I already thanked you, but I'll thank you again. Thank you. Evil Socket, thank you for the follow. Wolfie42, thank you for the follow. Erickson, thank you for the follow. And Surrender, I don't think I got you either. Thank you for the follow. And Dana Webb, thank you for the follow. Much appreciated. Good to have you all here. Polka says, will you be attempting advent of code in SQL? No, mostly because I forgot it exists. But I am trying to work my way through all the SQL 50 columns, all the SQL 50 questions here on LeetCode. Just doing them in bits and spurts as I think of it. Yeah. But I am kind of doing the SQL 50, which is kind of the same thing, I guess. But yeah, so I'm going to comment this out and let's do it. Let's see how different this looks without having. All right. So without having, I essentially still have to do some kind of a two-step process, right? I have to do my grouping first. So this is going to be very similar to what we've already done. So I'm actually going to copy and paste the first part of this. So I'm going to select class, and then I need to grab my student count from courses, and I need to group by class. So that's step one. I'm going to put this in parentheses because this has to happen first. And then I have to do a secondary calculation against that, right, to filter on, to return only the classes that have the student greater than or equal to 5. Okay, so how can I do that? Well, I could use what's called a CTE, or a common table expression, which essentially allows us to turn all of this into a temporary table and then query off of it a second time. So I'll show you how that looks. I'm going to call this count. with counts as, and then, so essentially I'm creating a table called counts and I'm putting all of this data into it. And then I can do my second calculation, which is just select class from counts, which is the table I just created there, where, what do I call this? I call this class count. Now here I can use class count. I create it as a field in my temp table. Yeah. So this should have the same result. I'm creating a subtable or a temporary table called counts. And then I'm selecting class from counts where the count value is greater than or equal to 5. So that's a lot messier, right? I mean, it's not bad. It works, but it's definitely longer. It's definitely harder to read. And there's nothing wrong with common table expressions. They absolutely have their uses and there's reasons that you would use them. But in this case, we actually have a keyword that can do all of this for us in one line versus having to write it as a, a CTE first and then do a second select off of it. But we'll just go ahead and run this too. It's all good. Yeah, so this gives us the correct result, right? The second one, but it kind of sucks, right? It's kind of yeah, it's hard to understand, right? Your brain hurts, exactly. So I'll format it a little better for you, but yeah, uh, essentially all we're doing here is we know we have to do it in two steps. First, we have to put put the counts in the right buckets, and then we have to filter to return only the buckets that have a count greater than 5. So if we have two steps, one way we could do it is create a table that contains the classes and the buckets and puts the counts in the buckets first, and then a second select statement that only returns the records that we want. Yep. When I say, and that's a good point, that's a good clarification. I realize that not everybody might know what when I say temp table, what that means. So when I say this is creating a temp table, what that means is a temporary table, a table that only exists for the duration of this query. So let me show you what that looks like. So I'm just going to do a comment this out. I'm going to do a select star from counts so you can see what's in it. So essentially, I'm going to create the table first. This table only exists for the duration of the query. And after the query is finished running, it goes poof, it disappears. So it only exists in memory while the query is being run. And then as soon as the query is over, it goes poof, it's gone. But well, I'll just show you what's in there. So I'm creating the table first, and then I'm doing a select star from it at the same time. Yeah, I know, wrong answer, wrong answer. But when I do that, we can see that it created a temporary table, and I did a select from it, and it has all the values I would expect. All the values that I added here, then I can do a select star. Or in this case, I can only select the values that I need that meet the criteria that I want. But like I mentioned, this is less intuitive than a specific keyword that just does the job. So if you were in an interview, you could do it this way and you could get the right answer. But if you turn around and you whip out the having keyword and you're like, but wait, why don't we do it this way with a keyword that's dedicated for this exact purpose? Then this is the way you should do it because it makes much more sense and is much more readable in this particular case. So I'm going to take out the second value here to only return what the question is asking for. And that's the right answer. It returns math. Cool. All right, let's submit it. Hooray, we did it. Now, one thing I want to do real quick here is I'm just genuinely curious if so this, having runs a little more slower than, some other things. I want to see if using a CTE is faster. It might be. Oh, I should have submitted. It might be. I think, and that's one of the main That can be one of the main selling points of CTEs. Sometimes you can speed up execution by using them, but for sheer readability, I think this is better in this case. But that gets into optimization, and y'all don't have to worry about that now. Yeah, it was faster. So, but that's okay. Doesn't matter so much in this case. Sometimes you need to balance. Sometimes you need to balance readability versus efficiency, right? It's kind of like the Code Wars dilemma, where you can, if you can do something in a one liner, should you do it in a one liner or should you make it as readable as possible, right? So there's always considerations that go into that. In this case, I prefer this solution right here. All right, so I think we're going to wrap up for today. But I do want to, I want to hang around here on stream until 7 o'clock and just kind of chat with y'all a little bit, because I like to do that, at the end of streams. And I don't think I've had the time to just, I don't know, chat, have conversations with you guys, and see what's going on with chat and answer any questions that you all have. I don't think I've had the chance to do that at the end of my last couple streams, just because I've been busy. So if y'all have any questions about me, or about 100 devs, or about SQL, or about what I do, or about being a software dev, or anything like that, feel free to ask away. Evolve Into Me says, how do they expect new people knowing all values? Are you talking about the keywords that we've been talking about? Because if that's what you're asking, then the answer is yeah, okay. So if that's what you're asking, the answer is you're not going to know them. You're not going to know all the keywords. However, you should know the most commonly used keywords. Things like where clause. How do I do a select statement? How do I filter it using a where clause? How do I do joins? Left join. I told you there's two types of joins you should know: left joins and inner joins. And then how do I do a join on multiple criteria? We talked about using the on keyword to do one criteria, then the and keyword to do more criteria. So stuff like that, like the stuff that gets used all the time, you should have that down pat. If you're going to interview for a SQL job, you should know how to do a simple select. You should know how to specify the table using from. You should know how to use a where clause to filter your rows. You should know how to do an inner join and a left join, and then that join on multiple criteria. And then you should also probably know how to do things like a count and then a group by. And then if you want to get a little fancy, you can whip out that having keyword to bring your analytics up to the next level. But really, I mean, those are kind of the main core keywords that you should know. Are there a lot of other keywords out there? Absolutely. Heck yes. There's keywords that are, specific to specific flavors of SQL that only exist in, Microsoft SQL or Oracle SQL, whatever. Do you have to know those? No. You'll learn those on the job, if your team is doing stuff like that. But you should know the basics, the common ones. And Renee says, doesn't the runtime of a query depend on the traffic to the database? Yes, it absolutely does. And I've actually been testing that, Renee, while I'm doing these lead codes. I'll usually submit the same answer, like, a few minutes apart, like multiple times, and it's different. So, I mean, I've read before that CTEs can be faster, and that's what I see reflected here. But if you're looking at execution time in lead code, um, it's going to vary a lot from execution to execution, because yeah, it's all about traffic. So people, like in lead code, people will be bragging like, ooh, faster than, this execution was faster than 99.9 or whatever, or faster than 95%. Well, yeah, it just depends on traffic mostly. So yeah, that's a big factor in execution time, because I've done a little bit of informal testing, and it varies a crap ton, just depending on how many other people are doing stuff at the same. There are certain ways, that you can specifically optimize queries, but in general, on lead code, a lot of variance. Um, Robodom says, how much time of your day as a dev do you commit to documenting on projects or tasks? Yeah, that's a great question. So, you know, documentation can sometimes be a challenge. Um, and so I am one of those people, I firmly believe that good documentation is one of the most valuable things you can give to your team. Um, because it saves time in so many little ways. So if I am coming back to do a process again, like if I do a process at the start of the month and I come back to do the process again at the start of the next month, I'm not going to remember what I did the first time. So I'm going to have to waste time, you know, digging up emails or running queries just to figure out what I did last time. And then you can save time and money by just documenting it right from the first go. So in an individual day, I mean, I don't do documentation every day, but it is something that I do try to spend, anytime I come up with a new process or I encounter, or if I struggle with a process. So if I go through and somebody says, "Oh, we do this twice a year, go do it," and I'm like, "Oh my god, I don't know how to do this at all. There's nothing written down. I'm just flying by the seat of my pants here." Once I figure that out, sure as heck, I'm going to spend a whole day, maybe, documenting that entire process, so that the next person doesn't have to suffer. And that's something that a lot of teams overlook, because it's not fun because you're not really producing anything, right? You're just writing stuff down. And we have this sort of internal false idea that right after we've done a process, we're like, oh, yeah, that was easy. I'll remember what I did. Yeah, I mean, I'll remember that next time. Spoiler alert, you will not. You will forget everything. And then the next time you go to do it, you're going to have no idea what to do. So but that's a general sort of an attitude that is kind of tends to permeate teams, is not wanting to document because it takes time away from actually producing work. um, but what they overlook is the time savings that come from good documentation, which then frees up more time to do actual work, have the documentation. So it's it my time spent documenting really varies, but if I encounter something that needs to be documented, I am sure as heck going to carve out time to do it. Robodom says, I'm working on refactoring a legacy site. I'm finding that documentation is very crucial. Yeah, absolutely. I'm finding it hard to commit more time and energy during my week to work on documentation. Yeah, and it depends on, your aptitude and proficiency for writing as well. I mean, for for folks that maybe, just aren't great writers, and not everybody is, then documentation is a lot harder. I'm pretty passionate about writing. I like to write. I enjoy it. And I like grammar and I like vocabulary in English and those types of things. So writing comes fairly easily to me, but it doesn't always to everybody. And it takes a lot more mental energy sometimes to do something that you aren't inherently skilled at. And I'm not saying you're not, Robodom. I'm speaking in general. That takes a lot more mental energy, and it can be a lot easier to just be like, nope, I'm going to focus on just the code itself. I'm going to get the work done, and then I'm going to be done with this. And so yeah, it's not an easy task. And some of my teammates on that I currently work with, they're just like, nope, I'm not going to, they're not going to bother with documentation unless it's absolutely necessary. Um, so everybody has different aptitudes for that kind of thing. Robodom says, I could work on improving my writing skills. I feel like everybody could. Yeah. English is hard. Even though I like it, even though I like writing, English is hard, man. It's a weird language. Definitely. It makes zero sense. Yeah. Especially if you're not a native speaker. I mean, man, I'm a native speaker and writer of English, and like, man, grammar sucks. So if you're not, like, if that's a second language or a third language or whatever, then I can't imagine that would be so difficult. Any other questions? Figure I'll stick around until top of the next hour, so about 15 minutes. So we got plenty of time for more questions. Are there any? I'm curious. Let's see. We got many people stuck. We still got 65 people left on the stream. So I'm I don't have right now. I don't have any friends in the area who have seen the Doctor Who episode from last. I don't want to give spoilers, but anybody else watch it? I thought it was great. Anybody else like Doctor Who out there? And yes, I do like I like both Star Trek and Doctor Who, so I'm happy to talk about it. Robodom says, "Wait, what show? Doctor Who? Come on." Rasfania, welcome to the stream, by the way, Rasfania. Good to have you here. They said, "Do you natives care about grammar mistakes?" Um, so in documentation, you generally want it to be as readable as possible. Now, does your grammar have to be perfect? Absolutely not. I have coworkers that, you know, I'm not throwing anyone specific under the bus, but some folks are better at grammar than others, and these are native English speakers. And so, as long as you get the point across, then you're probably going to be fine. And worrying about grammar shouldn't stop you from writing, because the only way to get better at English is just by using it more and having people correct you, and running your text through a spell checker or a grammar checker. There's a lot of great tools out there that can help you with grammar. um, if English is not native to you, you can use things like Grammarly. Things There's all sorts of free online tools out there. I mean, obviously there's spell checkers and grammar checkers in you know Google Sheets and Microsoft Word and all those things too, to help you out. So with documentation, I think what's more important is that it gets the correct point across, for each step, and that you are making your ideas understandable, even without having perfect grammar. Oh, God, really? You've been binging Doctor Who all week since you've been laid up. Oh, well, there's plenty to binge, certainly. Leo says, for when the Tales from the Query. Robodom says, I used to watch the old Doctor Who shows, but I haven't been keeping up with the new series, even though there have been notable actors from the show, like David Tennant. Yeah, absolutely. He's on there right now, by the way. The current Doctor, again. There's series 9. Oh, that's a good one. That 12th Doctor, Capaldi? I don't always know off the top of my head without looking. Or is that still? Oh, Capaldi. Okay. Cool. What other questions do y'all have? He's my second pick. Oh, that's awesome. I like him too. He's great. I first saw him in what's that show? The Thick of It. Yeah, he was on a BBC comedy show called The Thick of It, where he was like extremely foul mouthed. Great. So as soon as I saw he was gonna be the Doctor, I was like, this is gonna be good. Good questions for it. It doesn't have to be about Doctor Who or anything. I thought there would be more Doctor Who fans, and feel free to ask about whatever you want. But yeah, Robodom, I like David Tennant quite a lot too. Great. And Catherine Tate too. She's okay. Well, feel free to ask if you think of anything else. Other than that, otherwise, I'm going to go ahead and start looking for someone to raid. Um, David Tennant is the best. Oh, is he your favorite? He is pretty cool. I actually got to meet him one time at a convention. Him, and Catherine Tate. I got a picture with Catherine Tate. She was so sweet, lovely. They were both lovely, both amazing, so lovely and nice. All right, yeah, it was really cool. Oh, Robodom says, I'm trying to improve my skills as a dev, finding it hard to focus on a single project or concept. What do you recommend new devs do to focus on? Yeah, you should, if you can, I would suggest finding a passion. So something that, not a tutorial or anything like that. Find something that you as a person, are passionate about. What are you interested in? Like, what do you like? what bugs you? Actually, sometimes things that motivate me to build projects are things that just bother me, like things that annoy me. And I'm like, man, I could build a tool to automate this, or I could build a tool to help me get this information or do this better. Like sometimes I build out of spite, which gives me the most energy. I don't know. I'm curious. Is it anybody else out there sometimes build less out of passion than out of like anger and frustration at something being inefficient or that you feel like you could build it better because that sometimes that's my strongest motivator. Not anger at a person, but anger at like a process or anger at an existing tool. And I could do this better. So find something that motivates you that you actually want to work on. Okay, so you want to make a formal website. Okay, think about something you enjoy. Maybe it's a sport, maybe it's a charity, maybe it's I don't know, a particular topic. Um, and try to build a project around that because that's going to make you want to work on it. If you're working on something that's not fun for you, then yeah, of course you're going to be bouncing around. You're going to try it. Your brain's going to try to make you do anything else other than that. So I would suggest finding a project, focusing on, I want to build this thing, like have an end goal in mind. I want to build this thing. And then learn as you go while you're building it. You're not going to know everything up front. That's not possible. What you're going to do is you're going to start building it. You're going to run into challenges and bugs and errors. And then you're going to be forced to learn while you're debugging, while you're fixing things. That's going to embed those topics in your head and, actually help cement that knowledge for you. And then in the end, you're going to have a tool or a project or something that you can put in your portfolio. So it's really a win all around. Robodom says, I know my attention and motivation wavers a lot. Yeah, so I can speak to that a little bit. Um, I have always had that problem of not having a good attention span for things that didn't interest, or even things that didn't, like things that I know are important and like I should do. Um, but I just couldn't focus because there were other more fun things to do over there or something else. And I would make excuses and I would put it off and I would, just not be able to focus or pay attention or absorb things. And then actually earlier in this year, I was evaluated for ADHD and diagnosed with ADHD. So I'm not saying that you have it. And I don't, I do, I'm not going trying to diagnose anyone, but I'm just saying that there are certain causes for chronic inattention. One of them could be ADHD or numerous other things. Um, and so, with that in mind, you have to be aware of your own limitations. So, you can't necessarily say, I just need to be more motivated, right? Or, oh, I just need to buckle down, right? I just need to try harder because that doesn't work. Sometimes your brain is going to be its own worst enemy and it's just not going to allow you to do those kind of you have to learn how to work within the architecture of your own head because not everybody is wired the same. Some of us have certain limitations. And so, for example, some things that can make it easier are finding something that you really do enjoy, finding a topic or a theme or something that you're passionate about or angry about. And that will cause your brain or force your brain to focus harder on that thing um, and give you more motivation because motivation is almost impossible to conjure from within, especially if you're someone who has inattention problems like I do. I know this personally about myself. Is that I almost can almost never just conjure motivation from. I have to have some kind of exterior driver. Now, sometimes it may be medication if you're properly medicated by a licensed physician. Um, which for me it's partially that now. But other times it may be something like the reason I started streaming, the reason why I do this right now is because I was going through the 100 Devs program, trying to learn to be a web developer, something I wanted to do. I wanted to learn to program, but I couldn't stay focused because learning is hard. Um, Writing HTML is hard, writing CSS is hard, writing JavaScript is hard. I couldn't focus. Um, and so I started helping people learn the material. I started teaching others the material just on Discord because that helped me create a feedback loop to then internalize that stuff. And so then that in turn turned into a larger audience, people who were relying on me to help teach them, to help teach them the material. So I knew I had people at outside people counting on me to learn the stuff first so that I could turn around and teach it to them. And so that was my outside motivation. I didn't have to conjure the motivation from inside myself. I had to, well, I was getting it from outside sources. So that took the weight off of me and forced me to learn the material without any extra effort on my own part. So there's a lot of different ways you can do that. You can find a buddy to work with, right? You can find a buddy to build projects with. You can, you could commit yourself to teaching somebody else the material who's behind you in the learning journey, right? Um, you could, find a client, right? You could you could do a trial by fire and find a client and say, hey, I'm going to build you a website in 6 months, right? And then I have to do X, Y, and Z in 6 months. You can put time pressure on yourself. There's lots of different ways you can do it. But just know that just saying, hey, I need to be more motivated, not always going to be possible to conjure that from within yourself. Sometimes you need to find outside structures that can provide that motivation for you. In my case, that's very true. It was a very long answer, but I hope it was helpful. I missed a couple followers here. Wolfie42, thank you so much for the follow. Oh, sorry, I already thanked them. Altora, thank you so much for the follow. Good to have you here. Lutrep, thank you for the follow. And Pexitons, I may have already thanked you, but I'm going to thank you again. I hope y'all are having a great day, and thank you all for stopping into the stream and for the generous follow. I love it. It's so many new followers today. It's great, and so lots of new viewers as well. Great seeing you all here. And also, if you are a new viewer, I have a massive stream archive. If you read my About Me description there on my video page, I am a SQL developer, but I'm not primarily what I do here on stream. What I mostly do here on stream are full stack projects related to web development, using things like React and JavaScript and MongoDB. Um, and so like non-SQL stuff. So if you're interested in any of that, I have plenty of that stuff on my archive as well. So, and also my entire archive is on YouTube, and my YouTube channel is not monetized on purpose so that you never have to watch an ad. That's very important to me. I hate ads with a burning passion. And so I have turned off monetization on my YouTube channel so that you never have to watch an ad and you can see all of my archive ad free. And if you're interested in that, no, right? Ads. If you're interested in that, you can do !YouTube in chat to get a link to my YouTube channel where you can see. I think it's over 2 years of archive videos now on all sorts of different projects and topics. So if you're interested in, maybe an idea for your next project, like Robodom, if you're interested in an idea for your next project, um, and you're maybe you have a broad concept, but you're like, I wish I had a little helping hand to get me started. Um, that's a lot of what I do on this channel is we build the basic foundations for all sorts of different kinds of projects and then let you flesh it out with your passion and your personal interests and your creativity. Okay, cool. Well, let's go ahead and find somebody to raid. It's about that time. Feel free to ask any last questions if you have them. Otherwise, I am going to be looking for someone to share the love with here. Oh, no worries, Copper Lily. I hope you feel better soon. That sucks, man. I hope you're able to watch a lot of Doctor Who, and I hope you feel better soon. Yeah, absolutely. Thanks for stopping in today. Who do we have? Do we have that we can raid today? Leo says, what have you watched lately you liked or even found inspiring in some way? Are you talking like TV, YouTube? Let me think. I have a lot of like on you if you're talking like learning type stuff. I have a lot of um, content creators that I really like on YouTube that are, educational content creators. Bobby Broccoli is a really good one. They talk a lot about like interesting scandals and stories in science. Yeah, I can type the name. Let me see if I spell it. Yeah, it's a slightly odd spelling. I think it's Bobbi. Actually, I'll just search it up on YouTube here. Otherwise, I'll get it wrong. But just really entertaining. Oh, okay, here we go. Yeah, so I really like this person. Make sure that hopefully that was the right person. I think so. Yeah, it's them. That's them. Bobby Broccoli. They're just really interesting videos. I like them a lot. Yeah. Other than that, let's see what else. I like kind of a weird niche thing, but I like watching documentaries and reading stuff about like scams, like scams and cults and that type of thing. That the type of thing that people get sucked into and lose all their money and that I like reading about those just because it keeps me more alert and aware because there's all sorts of scams and frauds going around. There was a really good documentary on HBO Max called "The Cult of Mother God" about this lady who like literally formed a cult, a really weird cult around herself, and then like died. And it's a wild ride if you have Max, HBO Max. It just shows how anybody can end up in a cult, even if it just seems bizarre and weird to everybody else. That you are not immune to falling for a scam or falling for a multi-level marketing scheme or ending up in a cult. It can happen to anybody, no matter your education level or your income. It doesn't matter. If you get hit at the right time, you too can end up, you know, giving all your money to some random person. Yeah. Oh my goodness. Thank you so much for the sub. Wow. Iced fire. You're so lovely. Thank you. Really appreciate that. Hooray. What a way to end the stream. Hey, Chub Shobi. Welcome to this stream. Good to have you here. And Chub Shobi says, "Are you on Windows XP?" Oh yeah, I was going to mention that. I forgot. Yeah, so Chub Shobi very astutely noticed my background, which is the infamous. It's the infamous Bliss background from Windows XP. Yeah, look at there it is in all of its glory. It's beautiful, isn't it? So Microsoft every year they release an ugly sweater like some kind of a Windows or Microsoft theme. This year, their ugly sweater is the classic Bliss background from Windows XP. And on their site, on the same site where they have the sweater, they also have a 4K download of the background of Bliss, which is what I'm rocking right now on my QHD monitor. I love it. It's great. I'm so glad somebody noticed that because yeah, it's just the best. I do miss Windows XP. Yeah, I actually used to use like the little helper dog. Does anybody else remember that? So like there's Clippy, right? There's Clippy, the little paperclip. But then there was also Rover, the little helper dog. And you could like use him to help like search for files and stuff. I used to use Rover when I was young. I thought he was so cool. Little 3D helper dog. Thanks again for the sub, Ice Fire. You're so lovely. All right, who do we got online? Yeah, Rover. Somebody else. Oh, good. Somebody else remembers Rover. I was feeling like I was going insane there for a minute. Okay. Ooh. Oh, okay. How about so we've got a few people that we could choose from. CM Griffing, they're great, obviously. Um, we've got Dorchenheimer, we've got Team Vash, we've got Wallaber. Looks like Wallaber has the fewest viewers right now, but they are doing some software. Ooh, they're doing some game dev. Oh, it looks like they're doing some game dev on a driving game and they're improving their driving mechanics. So that actually sounds pretty cool. So they're doing game dev. So why don't we check out? Yeah, that does sound fun. I want to see what they're working on. So yeah, let's go ahead and raid Wallaber, see what they're up to, see how they're making. Looks like they're making some kind of a racing game. So I'm up for it. Alrighty. No worries, Leo. Good to see you. And I will see you all again next week. Probably not going to be doing more SQL next week. We're probably going to go back to our more regularly scheduled projects and that type of thing. But I hope you all enjoyed this sort of a little bit of a more in-depth look into SQL and how we can use SQL to actually manipulate data and get some insights out of it. So hopefully this was helpful for you. And let's go ahead and start the raid. I will see you all next weekend. All right, raid is starting now. 5 seconds. Ready. See you all again next week. Thank you for the follows.